sign up all the time and miss it. This is my first time not having a meeting while this is going on. Yeah, fair enough. Yeah, that's how it goes. That's how it goes. Sign up for things, don't show up. Nah. It is weird though, without the whole price thing. I've been trying to figure that out. Like, what is the... Because that's the whole deal, right? If you charge somebody $1, if you charge Eli, you gotta be smart about it. You gotta charge people something. Maybe you don't charge them a lot of money, but you charge them a little bit of money, so they think about what they're doing. All right, so that's the issue, right? If I charge $1, if I charge $1, I charge $5. All right, one, I get $1, I get $5. That would be nice. But then two, it makes people think about whether they want to sign up for the meetup. But the issue is what if somebody doesn't have a credit card? What if somebody is too young to have a credit card? Especially online. What if somebody's in Iran or Russia? Literally, they're not allowed to use the credit card system. Again, that's the interesting thing to think about. Let me talk about equity and crap. Again, why I love to listen to progressives talk about equity. There is nothing more amusing than hearing people talk about equity who have never actually had to build a goddamn system in their life. They're talking about what businesses should do. You're like, yeah, but... It's like right now, they want this whole rent moratorium. So I'm in Asheville, North Carolina, complete crap show. Anyways, there's this idea of a rent moratorium, right? That's what the progressives say. Rent moratorium. But here's the thing. There's not a mortgage moratorium. So they want the renters to not have to pay rent in this time period, but the people who own the properties still have to pay their mortgages and their insurance, and wait for it, their taxes too. There is no property tax moratorium. They just want a rent moratorium. And they're like, Bucka, this crap ain't gonna go well. Anyways, that's what I think about, like with the whole people sign up and they don't show up. So it's like you say, well, charge $1. If you charge them $1, that makes them think about what they're doing. But the problem is like a curb, right? A curb that big. Eli, it's just a curb that big. But again, a curb that big for somebody in a wheelchair might be a mountain that's too high. And so it's an interesting thing. It's an interesting question. Again, if you care about DEI, if you actually care about DEI, nobody actually does, but if you do, if you actually think that you're a progressive and all that kind of stuff, do you think about that? How do you actually build the systems that are functional? It's a hell of a thing. It is a hell of a question. Here online it doesn't really matter, right? Because you either come or don't come. Doesn't cost me a cent. Doesn't cost me a cent. Doesn't cost me any energy. If I got 1,000 people watching or I got 5 people watching, doesn't matter. Now, it is interesting though, again, in the physical world, right? I've only got so many seats. Physically, there's only so many seat resources. So if you have 20 people sign up and you only have 10 seats, that's a problem. And if you have 20 people sign up and only 5 people show up, right, you get into this weird crap show. And again, what is the answer? I don't know. I think about that. Like again, you think about what is the appropriate wall? What is the appropriate barrier? I think about that. I was in Calcutta in India, right? So anyways, I go to India. So I was in India for 4 months. And I've been told that USAID libraries have air conditioning. Or if you've been in India for a while, you kind of miss the air conditioning. Anyways, so I'm in Calcutta, and I decided to go to the USAID library. And I don't know, it's somewhere. So you go into this building, you go up the elevators, you come out the elevators, and there's this nice Indian woman there. She's like, oh, hello, thank you for coming or whatever. And she was like, it'll be 10 rupees to get in. And again, it's USAID, so it's American. And I know the value of money. I may not know the value of life or love or anything else, but by God, I do know the value of money. So anyways, I'm like, 10 rupees. So back then it was 45 rupees to the dollar. So 10 rupees is, 20 cents. It's like 20 cents. Like, it is an amount of money, but not a real amount of money. Totally. So I'm talking to the woman. And this is what you gotta do. Again, for other progressives out there, go talk to other people. Go talk to people that aren't like you. Anyway, so I'm sitting there in India talking to this Indian woman, going to this USAID library, and she wants the equivalent of about 20 cents. And so I look at her, and it's like, look, I don't care. Again, I'm not a poor backpacker or whatever. I can pay my 20 cents. So I give her my 10 rupees or whatever. And I'm like, here's the 10 rupees. But just out of curiosity, like, why? Why? 10 rupees is 20 cents. This is an amount of money, but it doesn't actually matter. Why am I giving you 10 rupees? And she said, oh, well, here's the problem. And she got the biggest freaking smile on her face. I was like, okay. She was like, well, we had this problem where homeless people, and it is India, there's quite a few of them, found out that USAID libraries had free air conditioning. And so they would have homeless people, the doors are basically open, so homeless people would come in and they would just camp the hell out. But it's understandable. If I was homeless in India and you told me there was free air conditioning, I'd go for it too. So they were trying to figure out a way to deal with the homeless situation. And one of the big problems they have in India is the whole caste system, right? You have the Dalits, you have all these different castes, and so there's a lot of people out there. No matter how smart you are, no matter how much money you are, if you are of the wrong caste, you are screwed. And in America, we don't believe in that. We judge you on the size of your bank account, not necessarily on the color of your skin. So the Americans were trying to figure out how to solve this problem. Like, yeah, right. We don't want to reject people just because of some arbitrary thing, but we do need to not have the homeless people camping out in here. And so that's where they came up with the idea of charging 10 rupees. And this woman's face, and again, if you really want to understand the value of the United States, you should have seen this fucking Indian woman's face as it lit the hell up. And she was like, that is the great thing about America. All you need is 10 rupees. They don't care who you are, as long as you give us 10 rupees, you're allowed in. And so 10 rupees was a barrier that was too high for the homeless Indians to get through, and it was low enough, most people didn't give a damn about it, and so that ended up being the rabbit-proof fence of the USAID library. Which again, it's an interesting thing about these modern worlds. How do you build systems? How do you build the systems? How do you build the structures that will create the outcomes that you're actually trying to create? Good systems default to good outcomes. Bad systems default to bad outcomes. Anyways. Ta-da! Soapbox. Oh, let's see here. I don't think as many people would miss if there was a charge. Yep. But then people might not come. What is $1 worth? Is $1 worth your future? Again, I think about that, like in the Army, right? So when I joined the Army, long time ago, can you believe, what is that? Oh, about 96. 30 years ago. Nothing in my life should have happened 30 years ago. But anyways, I joined the Army back in 96. And one of the interesting things there was the GI Bill. Right? So there's something called the GI Bill and the College Fund. So when you join the Army, one of the benefits is you get college money afterwards. The GI Bill is basically given to everybody. We'll get to that in a second. And then the College Fund is like an additional sweetener for people going to specific MOSs. So I got the College Fund too. But the interesting thing is in order to get the GI Bill and the College Fund, your first year, you had to pay $100 a month in. Right? So like with the College Fund, my full thing at the end of the day was about $30,000. It was less than that because I didn't serve my full time, but it's supposed to be about $30,000. So basically, essentially the idea is your first year, you pay $1,200, and when you get out, you get $30,000. Which, I mean, that sounds good. That sounds good. Well, Eli, look at these soldiers. These soldiers can pay $1,200, and for that, their return on investment is $30,000. Eli, how can you possibly be snarky about that? Because I deal with humans. Right? The interesting thing about humans is I met so many folks who joined the Army and they had it in their heads that they would never go into college. Right? They're from wherever, they're from a working class background, they're going into the Army, and they're going to be soldiers, not college professors. Right? They're warriors, killers. They ain't gonna learn no Latin languages. Well, the funny thing is, and so that first year they have the decision. They have the decision to make. Do you pay $100 a month, $1,200, and you get $30,000 at the end of your 4 years? Or do you not pay that? And so there's a lot of folks out there, there's a lot of soldiers out there who decide, one night of drinking a month, they'd rather have that money because they're not going to go to college anyway. And then the funny thing is, people grow up, especially when you're in the military, you grow up a little bit and go, wow, this whole warrior thing might not be what it's made out to be. And you're like, damn, I really want to be an accountant. And then all of a sudden, you did not pay $1,200 into the system, ergo, you did not get $30,000 out of the system. And again, it's an interesting way of how the American government screws our soldiers and yet expects them to go over and kill brown people for some reason. But again, it's kind of thing to ponder, to think about, right? So if I require a dollar, and you think, I don't know if I want to give $1. I don't know about this Eli. Maybe he's not worth $1. And so you don't pay $1, and then you don't come. What if you came to the class and you realized you like technology? What if you came to the class and realized you could do technology? What if you came to the class and you realized the opportunities that were available? And because I put a $1 barrier, you don't get that lived experience. Is $1 to me worth your entire future? Again, the things that I ponder. The things that I ponder. Don't get drunk with me. You will not enjoy the experience. Anyways, we got some people here. It's about 10 after, so we are going to get into the class. So again, welcome back to Silicon Dojo, a third-less gatekeeper that's free to the end-user hands-on technology education that empowers you to do whatever the hell it is that you want to do. So basically the idea is I've done YouTube education since 2009. Again, 15 years at this point in time. And the idea is, hey, what if we change things up? Again, I want to do this stuff actually in person, but what if we come up with another model for doing education? Again, especially with the whole interactive thing, that's what we're doing here. This is free to the end user. Basically, you can just show up and you can learn. No questions asked. The idea is to abstract the financial component from the educational component. That doesn't mean it's actually free. Stuff costs money. We do have a donor box account. There's a link somewhere. I do need to make it a hell of a lot more prominent, but if you find these classes valuable, if you want these classes to continue, and if you are able to pay and can swipe a credit card, there's a donor box link somewhere. Would really love you to put in a recurring, $5 a month. $5 a month from a whole bunch of people actually is an amount of money that matters. The election happened. If you're in the United States, wow, how was that? I was kind of surprised this morning. Gotta admit to that. One of the things I'll say for a lot of people, there are a lot of people out there that are stressed and depressed and crying. Oh my God! One of the things I'll tell you, again, with the election going on, is at the end of the day, how much is it going to actually affect you? What can you do to make somebody's life better today? Right? I planned to do this class yesterday. The election happened. I'm still doing this class. Does the election affect me teaching you folks and trying to empower you to make your life better? No, it actually does not. Again, I've been doing tech education now through Obama, through Trump, through Biden, back through Trump, and what I gotta tell you is no president has actually made a hell of a lot of difference on this whole mess. So just kind of think about it that way. Asheville, just so you know, I am in Asheville, North Carolina. This place is an absolute and utter disaster, and I don't know, that's just how it is. Keep us in your prayers. We are doing new meetups. So we are going back to the in-person. So for about 2 years, I did in-person classes. It was wonky, whatever. That's one of the reasons we're doing the online thing now. But we are going back to do the in-person classes, just so you know. So if you go to Meetup, you will see we have the online Meetup that you are part of. We are going to be having the Asheville Meetup. getting a space, or getting a conference room, basically a conference room here in Asheville, so I'll be able to teach up to like 8 people at a time, and not next week, probably the week after, we're going to start having classes every week, maybe 1 to 2 classes, still got to figure it out, still got to talk with people, but these will actually be in-person, hands-on classes where you sit there with your computer and go through the code, so I can help you all out. The good part about this is I can actually help you out. It's a hell of a lot easier when you're in front of me, I can actually see you, and then 2, you actually meet people. Again, I do remember with this profession, it's not what you know necessarily, it's not even who you know, it's who knows you. The more relationships that you create, those are the things that are going to make you successful in life. So we get people to come together, and they get to know each other, they create their own network, and hopefully things get better. Along those lines, we do have the Research Triangle, so Raleigh, basically Raleigh, North Carolina. We are going to be doing a meetup there. So basically with that, or classes there, I'm planning to spend 2 to 3 days per month-ish, somewhere between 30, month to month and a half. Go up there, basically do 2 to 3 days of classes. Actually, still have to find a place to do this. This is in the planning stages, but this does exist. So if you're up in somewhere in that Raleigh Research Triangle area, you might want to sign up to one of those meetups. That's there. Social media, just so you know. So for all the notes and everything, we do have a GitHub account, Silicon Dojo Online Classes. These are all the notes that you can just come here and you can get, and these are free, not just for you to use, but also to do with as you see fit. If you are in Mogadishu and you want to use this material in order to train people and you want to charge money to train them, go for it. The videos generally afterwards do go up online. I have a camera right over here that is recording everything in 4K. It is amazing, the quality of 4K versus the quality of Zoom. Anyways, if you want to watch these later or if you miss them, they will almost always be on YouTube afterwards on the Eli the Computer Guy channel. And also, if you want to follow me on LinkedIn, this is the only social media that I use. Anyways, I'm there. I don't know, I've got 2,000 followers and 500 connections or whatever else. If you want to follow me and see what I talk about there, you can do that. And I think that's about it. That is what we've got for today. If you have a question, do make sure to ask a question by going down to React and raising your hand in Zoom, wherever that is on Zoom. Again, if you raise your hand, just by raising your hand, I will not be able to see it. There's nothing more adorable than looking at the video feed every once in a while and seeing somebody do this. You're like, oh, that doesn't work. Anyways, if nobody has any questions, we will get into our intro to cloud computing class. So we're going to be talking about cloud computing today. The cloud, boss, the cloud. So I'm going to say something that's going to be really controversial. It's just a concept. Boys and girls, it's just a thing. SQL's a thing, CSS is a thing, HTML5 APIs are a thing, and so is cloud computing. You start talking about cloud computing and oh my golly, you find out who's the lame person in the office when people have some very big opinions on cloud computing. It's just used for architecture, boys and girls. There's no reason to expend energy on hating it or loving it. It's just a thing. It's just a thing. Calm down. Again, it is weird. You start talking about cloud computing, and it is amazing how many people start losing their minds very quickly. And you're just like, oh, man, I haven't had enough coffee for this. Basically we'll be going through here as we talk about this. So this is just a Pages document. We're going to be using this, I think, more and more for how we're going to be doing these classes. This is just easier. Instead of having a keynote presentation or PowerPoint presentation, having multiple different materials, kind of just creating this one document and then scrolling through it. I think it's better for everybody. You can print this out, you can scribble your own notes, you can modify it as you see fit, and we all know exactly what we're talking about. So anyways, intro to cloud computing. So what is the cloud? It's just the cloud. I don't know how do you explain the cloud. So again, I got my MCSE. I've been doing tech for a while. I am cranky from experience. And so here's the thing, right? So back in the day when I was getting my MCSE back in 2000, we were learning about LANs, we're learning about WANs and MANs and CANs and all the ANs, right? Well, the problem is you dealt with like the internet. So here's the thing, right? So, you know, you got your router, your modem here if you're drawing out a diagram for your network. It's like that, let's say that's your modem and that's your router. And then under that you have your switch, and that switch goes to, let's say, a wireless access point. Again, how things have changed. In 2000, we didn't have wireless access points. But anyways, you know, and under this you have your server. Let's say one of them is your web server, and one is your SQL server. And maybe under this, maybe this is what's called the DMZ. And then under this, you have your Active Directory server and your Exchange server and all your clients and all that kind of stuff. Anyways, right? So when you're sitting here and you're scribbling this out, and so you're like, okay, so I have a user down here, and they are going to connect to CNN.com, right? So you have like CNN's infrastructure, and so they have their router that goes in, and then that goes to a switch, and then that goes to an Nginx reverse proxy server, and then that, you know, goes to their multiple little web servers. And so basically the idea is, okay, this is what my network diagram looks like, and this is what their network diagram looks like. And in between, you're the cloud. The cloud. Here's the thing. In the cloud, right? All these different ISPs, internet service providers. There's connections, right? The cloud is insane, right? So like I'm on Spectrum, so when I come in, I'm gonna hit one of Spectrum's routers. Spectrum is gonna bounce me through a couple of their things. Then it's gonna go through some kind of connector that's gonna go over to some either ISP, and then it's gonna bounce to get over to CNN.com. Now here's the thing. That's the path that route is going to take right now. So you can do something called a trace route command. You run trace route to, let's say, CNN.com, and you're just going to get a list of networking equipment you're going to be running through. All right, so right this second, right? And so there's something called routing protocols, and so what routing protocols do is all these routers and the network equipment basically figure out the fastest way to get from point A to point B. Point A is here, point B is there. Well, here's the thing, right? That's changing dynamically. A backhoe goes through a T1 line here, power goes out here, router gets turned on here. Right? This is the internet. This is the internet. It's constantly changing. So this is my route now, but then I go back to CNN.com a couple minutes later, and then maybe my route looks something like this. And then the route looks something like this, and then the route looks something like this, and then the route looks, you know, something like, you know, gobbledygook, that. And so basically the idea is, I know what this looks like, I know what this looks like, this is the cloud, right? My instructor way back in 2000, he actually argued this might actually be the first true artificial intelligence. Actually something based off of responses and all that kind of something that is actively making decisions. So it'd be OpenAI by about 20 years. So basically, that's all we're talking about with the cloud. The cloud. My modem, their modem, the cloud. Right? The idea is just, right, it's just that logical thing. Again, a lot of times when we're talking about stuff in technology, you know, there's the physical, and then there's just the logical, how we're going to be diagramming all this out. And so that's the cloud. Then we start talking about cloud computing, right? Cloud computing. So that's the cloud, right? So this is the old days. This is the old days. And in the old days, right, you know, we'd have our racks. Prakash, you're coming in 21 minutes late. If I failed people, Prakash, you'd fail. I don't fail people. So anyways, you are in your facility. Oh, you are in your facility, and you got your server room with racks, right? So these are little 1U racks, 3U racks, whatever, right? And so one of these is the Active Directory server, one of these things is the Exchange server, one of these things is, let's say, the firewall, and one of these things is, I don't know, the file server. You got all these things going on, right? And so here's the deal, right? Email service fails. I, as a technician, can go, dat box. Where's the problem? Dat box. Active Directory starts futzing up. Where's the problem? Dat box. right? And so the idea was, again, go back about 20 years, basically the service, again, email, VPN, whatever, file services, whatever else, was basically super glued to the physical box. This box, right? This is my Active Directory server, right? This is my Exchange server. If email goes down, this is the problem, all right? Well, then we get into, again, the modern world. 15 years ago or whatever, we get virtualization and a whole bunch of technology we're going to be talking about. Clustering, and virtualization, and Linux containers, orchestration, inverse proxy servers, all that kind of stuff. And so basically what starts happening, again, even in your local environment, we're not even talking about in the cloud. All right, basically what happens is you start having these things basically called clusters, right? So you have all these servers in here, and these servers many times have these things called virtual instances, an instance of an operating system, basically like files. And so an instance of Active Directory, an instance of Exchange, maybe even an instance of the VPN server. And basically there's this cluster thing going on. So any of these instances at any time could be running on any one of these boxes, right? So now if Active Directory goes down or Exchange goes down, we just go, is down. Do I know if it's that box? I don't know if it's that box anymore. Because the operating system, the service itself, is no longer super glued to the physical hardware. The service is now this amorphous thing that can move around. It can dance based off of our configurations, right? And so basically, all I know is somewhere in that mess, something screwed up. Again, if we start talking, and this is what's called a private cloud. This is a cloud that you own, right? You could have a public. You could be on the public cloud, right? And you could be using AWS. You could be using AWS for one of their services, right? And so you got some server up on the cloud. You literally don't know where the hell it's at. You don't know if that server is quote unquote resides in your state. It's on the cloud. And so basically, the big thing to be thinking about when you start talking about cloud computing is what we're really doing here is we are logically going from a mentality where we can point to this specific box and say, that's the problem, to this more amorphous, like, well, I don't know, the box is somewhere. The box is somewhere. Ooh, there's boxes. Anyways, so that's what we're talking about when we're talking about cloud computing. Abstraction is going to be one of the big concepts that we're going to be talking about when we do talk about cloud computing too. Again, so we've talked about a lot with coding. In the coding world, we talk about service-oriented architecture, right? Architecture styles. So there used to be client-server architecture. So client-server architecture is, again, things like Active Directory. Fuck, you guys probably don't even know what Active Directory is. I just say these things. Like, does anybody know what Active Directory is? Anyways, there's this cool thing called Active Directory. It's client-server. Anyways, there's a client-server architecture, right? So the client-server architecture, basically you had a server that had an operating system on it and then it had some server service. And that was all super glued to that. Then you have your computer, and on your computer there's an OS, and there's a piece of client software designed specifically to communicate with the server software, and this is something called client server. And again, the issue with this is that basically that server service is super glued to that hardware, which is fine as long as you don't need to upgrade, migrate, move to something else. As soon as you need doing that, this turns to hell. And so that's why we go to this thing called service-oriented architecture, SOA. And with service-oriented architecture, when we're creating our code, there's just services, right? So we simply have an SMS service, so like Twilio. So this is where we start using APIs. We have an email service, like SendGrid, right? And so the idea is we have our code, we make an API call to one of these services, and basically we're just interacting with a service. We're not interacting with the operating system, we're definitely not interacting with the hardware. That's just right? And so if Twilio no longer suits our purposes, we can change a little bit of code and use a different SMS provider. Right, well, in the hardware world, or in the IT world, or whatever, when we start talking about cloud computing, you start kind of getting the same concept with hardware, with like computing infrastructure. What if we can abstract the resources and essentially make them their own systems, right? So if you've got a computer, right? So you have your old-fashioned computer, got a Dell Optiplex or whatever. So on this Dell Optiplex, you have a CPU, you have your RAM, you have your storage, you have some kind of networking component, and you have whatever else. Again, in the modern world, you may have a GPU, and that is all your server. So here's the thing. What if your product takes off? What if people start using your product and you want to upgrade your CPU? But this is all one box. That means you have to take this offline simply to do something like upgrade the CPU. Same with the RAM, same with storage, same with everything else. Since this is one thing with all of this stuff connected to it, it becomes a problem. So the question is, what if we can abstract, separate out these Jock, what are you doing? You were here, Jock, and now you're gone. People. Anyway, so the idea here is what if instead of this being one monolithic block, what if we could divide these out to be their own subsystems? And if they're subsystems, right, they kind of just get super glued together, again, with like things like APIs, then can we create better systems in order to deal with that, right? So like storage. So back in the day, if you wanted to deal with storage, you either had a hard drive or a storage drive, or you had RAID. Oh, RAID. I have stories about RAID. RAID sucked. So one of the problems in this world, if you're dealing with storage, you know, your redundancy is something called RAID, and RAID is garbage on the best of days. RAID was just trash, right? So, what if we could abstract this out? What if we could make storage its own subsystem? And then we make it its own subsystem, we can actually put in a lot more resilience and a lot more reliability and all that kind of stuff. And so now there are things called SANs. So these are called storage area networks, kind of like NAS's, fancier version of a NAS. But anyways, with this, essentially is what you can do is you can create a cluster of storage servers. You can configure redundancy and replication strategies and all that kind of stuff. And so now, instead of having the drive on your computer, and if that drive fails, you're screwed, and if you have RAID, you're screwed, now you can just connect to the SAN, right? All the storage is done on the SAN, and if one, entire server fails on the SAN, it is a cluster, and so the other ones just pick up the slack. If you have, again, once you start talking about infrastructure, if you have like lots and lots and lots of connections coming into the SAN, basically you can do load balancing. So one server in the SAN deals with that person, another server in the SAN deals with that person, and so you can actually balance the load for everything that's coming in here. So now that we can abstract out that storage component, we can do a lot of cooler things. Again, the same thing is true as like with a CPU. You get a CPU, you plug it in the system, that's all you got. What if we had a world where if I wanted to upgrade my CPU, I just swiped my credit card and said, I'd like another core, please. Hey, dear AWS, give me 2 more cores. Chink! And you got 2 more cores. Now you go from being a 2-core to a 4-core CPU. Because now your compute, so your CPU is the compute plane. It's called plane in the abstraction world. The compute plane is its own subsystem. So if you want 2 cores, you want 4 cores, you want 50 cores, you just swipe your credit card and you get 50 cores. Again, if you want a GPU, so you start doing AI, right? So you have this thing that you've built. It's been doing whatever it's been doing for a long time now. You want to add AI functionality. AI needs GPU. Well, you don't have a GPU installed in this thing. But what if you could just swipe your credit card and now you get GPU services, right? So basically the idea with abstraction is we're taking all of these things that were superglued, that were tied to that hardware, and then we're abstracting them out. We're turning them into their own subsystems, and once they're their own subsystems, we can do a lot of fancy stuff with them. Again, you got compute, you got storage, you got database, you got GPUs. All of this stuff is getting abstracted out. Let's see here. Along with this is, again, we get to the virtualized world. So back in the old days, we get to the cloud world. Back in the old days, servers were expensive. Servers were so damn expensive. You guys don't know what it's like, right? You go out there, you buy a Raspberry Pi for $55, and you're like, this is a ripoff. Like, what? You know what I used to be able to buy for $55? Like a 10-year-old computer. You had to hit on the side, maybe it would work. 133 megahertz, right? So anyways, back in the day, hardware was expensive, right? So if you go out there and you buy your server, and God help you with that RAID, right? And God help you too if you got something called SCSI drives, or these things called SCSI drives, right? This might cost you a lot of money, right? $10,000 at least. And that's before I get called in and charge another $10,000 to set this damn thing up, right? Anyways, and so this is your, your Windows 2003 server. And so the thing is, okay, it's $10,000 to buy this piece of hardware, $10,000 to pay me to set up this piece of hardware. You're talking about a $20,000 box. Here's a question, especially for a lot of institutions. How many $20,000 boxes can you buy? Probably not very many, right? And so the thing is, you sit there, you spend $20,000 on a box, you're going to put everything on that box possible. Again, I talked about something called Small Business Server from back in the day, and Small Business Server had Active Directory, and it had something called Exchange, and it had something called routing, routing and remote access services. That was basically the VPN service. And it had SharePoint. And it had file services. And it had a whole bunch of different things. Again, it was an absolutely great server. For about $400, you bought the license, gave you the CALs for something like 15 users, and basically you got all the fancy stuff. All the fancy stuff a major corporation could get, basically you could use in a 15, 20 person environment. The issue that you run into in this particular situation, though, is every piece of functionality you put on your server is a vulnerability, right? So we go back to our class in cybersecurity, and here's the thing, right? Everything you allow your server to do has some type of vulnerability, right? If you have a file server, that means you're allowing people to upload crap into your server. That's a vulnerability. If you have a VPN server, it means you're allowing people to connect to your local area network from the outside world. That's a vulnerability. If you have an Exchange server, right, that's doing a whole bunch of routing and all kinds of weird stuff, that's a vulnerability. And so the issue is when you have everything on this one box, if somebody can hack one thing, right, if I can just compromise one of these damn services, I can take over the entire box. And then everything goes to hell, right? And so that's a problem you deal with in a world where servers cost you $10,000, $20,000. Well, again, in the modern world, though, again, we got our nice little Raspberry Pis, and more importantly, we have what are called virtual computers now, virtual machines, and so these machines now cost nothing, right? You can go to Linode, right now, and for $4 a month, you can spin up the instance of a server. So what used to cost you $10,000, you now pay $4 a month for. Well, if I pay $4 a month, I can make that my FTP server, right? And then if I want, some kind of other stuff, let's say I want a web server, I pay another $4 a month and make that my web server. And if I want a VPN server, whatever, I pay another $4 a month, and that is my VPN server. It's the nice part about this, right? Because the cost of cloud computing has dropped so low, now our instances or our servers are only providing one service. So the thing is, again, especially if I build my network properly, again, we talked about that with cybersecurity, layered networks, multi-layers of security, all that kind of horse crap, right? So if somebody can compromise my FTP server now, then they've compromised my FTP server. My web server is still fine. My VPN server is still fine. My Active Directory server is still fine. Everything else is still fine. Yes, I have a problem because somebody's compromised my FTP server. I need to do something about that. But compromising my FTP server, just the FTP server, is a world of difference than compromising my entire server with everything running on it. So again, that's where we talk about the service-oriented architecture. These kind of concepts come in, and this is where we get into the services and the microservices architectures that you're going to be seeing when you start designing your platforms, right? So I am going to have, again, let's get there. You have one instance, one container, one blah, whatever, that is going to provide one particular service. Christopher, yes! Somebody other than Jock is asking a question. It's possible. Christopher, what is the question?
Hey, good morning, everybody.
Yep.
Or good afternoon, I apologize, New York time. For an FTP server when you're on a cloud, you're reliant on their administrators to maintain that security, right? If you're paying a certain amount per month. That make sense?
Oh, that gets into God knows what. So yeah, again, with all this stuff, I was like, well, it depends. So some of the security.
That's an okay question to ask.
No, it's fine. So basically, so let's say you have the FTP. So you want the FTP service. Again, we're going to talk about this with other cloud things. So you may just buy an FTP service, right? Again, you go to GoDaddy, you go to one of these things. They may just literally offer FTP, and you use that. If you go, let's say, with DigitalOcean, what would happen is they have what's called a droplet. So you create an instance of an operating system. You then install the operating system that you want. So we would do Ubuntu. On Ubuntu, we would install something called VSFTPD, most likely. I don't know, whatever the cool kids use nowadays. Or if it was Windows, you use something called FileZilla Server. And so basically, we would be responsible, so if we create an instance up on DigitalOcean, we are responsible for the operating system and we are responsible for the configuration. So if we do anything stupid with those, which might happen, that's our fault. Basically, this is all working within their environment though. So again, we start talking about instances of operating systems. So they're basically just selling their infrastructure. And so theoretically, I think this actually happened with Azure. And again, this is where you got to worry about security. Like, is it secure? Right? So like with Azure, what happened is, so this is running on their infrastructure. So with Azure, they were able to compromise what's called the host operating system or the host infrastructure. And from there, you might theoretically be able to compromise these instances. So you responsible for this. They're responsible for that. Again, how much do you trust them? Does that make sense? Oops, crazy. Oh yeah, don't remute yourself until the question is over, just so I can ask you and I'm not whatever. Yeah, that make sense?
Yes.
Okay.
Got it.
There we go. Yeah, we're gonna go into a lot of this, and it just gets into a lot of whatever. I mean, this is one of the issues too. You'll hear about this whole thing with security. The only thing I hate less or hate worse or whatever than talking about AI with people is like cloud security. Because people start going to this whole thing about whether or not the cloud is secure. Here's what I'm going to tell you, folks. Again, you know my bias. I was the owner. I've had employees. Here's the deal as an owner. Who do you trust less? Azure or your damn employees? So again, one of the things to think about with cloud computing is soon as you connect your box to the internet, it can get out to the internet in some fashion, it is now on the cloud. Right, is on the cloud. So when you start talking about security, who do you have more trust in? Is it your employees or is it Azure? You got to make that particular call. Anyway, so if you're good, I will remute you then. There you go. Cool. Yep. And again, if you have any questions, just feel free to ask a question. Again, there are no stupid questions. There are appropriate ones. If you try to go too far afield, I'll reel you in and we'll deal with it afterwards. Again, more than happy to answer any question. I just might tell you to do it after class, but that was fine. Okay, so the first thing to start talking about when we start talking about cloud computing is co-location facilities, right? So this is a big one. So basically what co-location facilities are is they're data centers for rent. So especially if you're a small company, if you're a startup company, I know what everybody wants to do. They want to build their own racks so they can have jet engines sounding in their fucking ears. Here's the thing. Let me be crystal clear. Before you go out and buy a damn rack for your servers, go out, plug in somebody's 1U server, and ask yourself if you want that damn thing sitting beside your desk 24 hours a day. So anyways, one of the big things out there, Wayne coming in at 40 minutes afterwards. Anyways, one of the big things out there is, again, building your own infrastructure. Like, I want to own my own infrastructure, especially in the beginning, so I can do configurations. What is the best operating system? Is CentOS going to be the best? Is Ubuntu going to be the best? I'll say it. Is Windows Server going to be the best? You might not know, right? So you want to go out there. If you have bare metal hardware, it's almost always going to perform better than a virtualized environment. And especially now, used hardware is dirt cheap, right? You can go out and buy Xeon servers with 128 gigs of RAM and a whole bunch of other stuff for like $500. Like, old hardware now is incredibly inexpensive. The issue is again, if you go out there and buy one of those 1U servers, there's a misery of turning one of those things on by your server, by your desk. And so one of the things you need to be thinking about is if people are going to be coming from the outside world to interact with whatever app or platform that you're creating, right? They're going to be coming through the broadband, the ISP connection that you have. If you have a residential grade ISP connection, that's going to be crap. How it fluctuates, you don't know, the whole 9 yards. So one of the things you can do is you can go to a co-location facility. This is where I started out with Everyman IT, and basically what a co-lo facility is they literally rent out either racks or rack space. So basically think of it as a hotel for your servers. And so you can go in there, depending on the fees and where the hell it's at and the whole 9 yards. There are some places you can get for $1,000 a month, you can get a full, like a 42U. So when I talk about U is like a server size. So that's U's. So you'll hear like a 1U server, a 4U server, a 10U server. That's sizes. Most of them you're going to deal with is going to be either between 1 to 4 U's. But anyway, so a 42U rack can hold a lot in the modern world. And so a 42U rack with a gig pipe going in, gig up and gig down, depending on where you are, might run you $1,000 a month. So think about that. And that is one amount of money that you pay and you don't worry about it anymore. If nobody comes to your site, you pay $1,000 a month. If the world comes to your site, you pay $1,000 a month. All you have to worry about is resource consumption. So basically all that happens with a colo facility. As you go there, you can generally rent by the U or by half racks or full racks. You put all of your equipment in, you configure it just like you configure it for your own facility. You'd use the ISP the IP addresses and anything else that they give you, and so that is yours. But it's now using actual, real world production grade data center infrastructure. Again, so cooling, the cooling will be appropriate. Well, hopefully it's appropriate. Go do a tour before you go there. The cooling should be appropriate. Backup power supplies. Again, think about this. Not only will they have the normal power supply coming in, but they'll have diesel generators and they'll have UPS backups for the systems if there's a failure that way. I used, I think it was called Tide Point when I was in Baltimore. One of the interesting things with them is they were on the fiber circuit for the government. For the city of Baltimore. So even if all the other internet in the city went down, that fiber ring that they had was dedicated for the government, so that was the last internet to go down if there was any kind of problems, and so that's where you could put Everyman IT, and it was fine. The good part about this is, again, you get that industrial grade infrastructure or whatever else. The bad part about this is you do still own this equipment, and so you got to figure out how the hell you're going to manage it. There's nothing quite so fun as when your server crashes and it's 20 miles away. This is where you get things like things called IP KVMs. I should put that in there. So there's something, keyboard video mouse that allows you to control keyboard video mouse, obviously. There's an IP thing. So basically what you do is you connect it into the back of your server, and you literally run a network cable, and then you can basically use a client to connect directly into those connections. So you can power cycle your server, you can do all the management functions, again, from a remote place. So that's kind of one of the things you have to consider. But there is the idea of a co-location facility, and that's the first thing to be thinking about in the cloud type world. Then we start talking about virtualization and hypervisors. So back in the day when we were talking about servers, we had a server, and the server had the OS and it had the service, right? So again, you had Windows Server with the Exchange service or the Active Directory service or whatever else, and this is all super glued basically into this particular box. The issue is if the CPU fan fails in this box, everything goes down, right? Literally had that happen a couple of times where people didn't connect the wires for the CPU fan properly, and the CPU, the power wire of the CPU fan would get too close to the CPU fan, and then after a year of the CPU fan hitting that wire, it would literally chew through it and then basically break the power connection, and then the CPU fan fails and the server crashes, and then everything kind of goes to hell. So basically the idea when we start talking about virtualization is what if we could turn this basically into a file? Just like you have a PDF file or a WAV file or whatever else, what if we could make the entire operating system, all its configurations, all its services, all of that kind of stuff, what if we could turn this into its own file and then be able to manipulate it like we would in a normal file? And that's basically what virtualization allows us to do. So you create something called a virtual instance. So you'll hear about virtual machines or instances, right? And you have something called a hypervisor. We'll talk about hypervisors in a second. So basically you have something called a hypervisor. And this hypervisor, you create instances of virtual machines. And within those instances, you install the operating system, you install the services, you do all the configurations, all the stuff like you would normally do. You install Ubuntu, you install VSTPD, you install the configurations, you do all that kind of stuff. But it is now this instance, and it's simply a file. And basically what you can do is with something called a hypervisor, we'll talk about it in a second, we can make this active. We can do what's called spin up. We can spin up this instance. And when we do, as far as our network is concerned, is that server is now just as legitimate a server on the network as if it was actually married to a piece of hardware. And so this is what we're talking about when we're talking about virtualization. When we start talking about virtualization, what's really cool is you get things like failover and load balancing. So, Alright, so again, before you have the server, the CPU fan fails, everything goes to hell. That sucks. That sucks. That's not useful. Right? Again, and that's the old day, right? That is the old day of dealing with backup systems. So I'll talk about disaster recovery systems in the modern world when everything kind of goes to hell. And one of the things to think about is backup. A very horrible form of disaster recovery. Basically, the server goes down, and then somebody's got to go and fix that server by hook or by crook, and that's going to take a lot of time. What if we had a disaster recovery environment where if there's a failure, things would automatically fail over, and then you would just grab a cup of coffee and look at the log file? Wouldn't that be nice? Wouldn't it be nice if a physical server completely and utterly failed, and instead of driving 20 miles to the server room, all you did was grab a cup of coffee, looked at the server logs, went on to your vendor and bought some new hardware? Wouldn't that be nice? That's where I get to with load balance, failover and load balancing. So let's say we have this rack. Let's say we have a rack of servers. All right. So before, Active Directory, Exchange, VPN, whatever else. Now what we're going to do is we're going to make these basically hypervisors. We'll talk about the hypervisors a little bit more in a second. So each one of these is a box, a physical box running this thing called a hypervisor. And then on these boxes, we run instances of servers. So I have an instance of an Active Directory server, I have an instance of an Exchange server, an instance of whatever else, right? So basically, when we start talking about failover, especially high availability failover is what you want. Buy it. It's wonderful. It's great. It's awesome. Buy it now. Basically what happens, right, is so in this environment, again, we start talking about cloud, Start talking about cloud. This is cloud, right? So where is my Active Directory server? I don't know, somewhere over there, right? So let's say my Active Directory server is down here. So let's say we got this particular hypervisor, my Active Directory server is there. Somebody didn't do the wiring on the CPU fan quite properly, and so basically this physical server dies. Kaput. Well, this Active Directory server basically is just a file. So what high availability failover means is that this system can literally just move that Active Directory instance of a server over to another physical box, and hopefully, depending on how fast it is, depending on how much money you spent, hopefully it literally can work so fast that your end users didn't even know it happened. So basically, this server goes offline, your Active Directory instance moved to a different hypervisor, you get an alert, you sit there, you look at the log file, and go, crap! You call the boss, tell the boss you need to spend $2,000 on a new server, and then, you wait for Amazon to ship it. You then get the new server from Amazon, you plug it in down there, you basically remove that server, this hypervisor comes up, and then these things are able to move around the instances as they see fit going forward, right? So basically, this is what we start talking about failover, and it is absolutely and utterly awesome. The other thing to be thinking about too is things like load balancing, right? So power consumption is a real thing in the real world. Everybody wants like those 4U servers, again, 1U servers. You see an 18-year-old, you give an 18-year-old a 1U server, like, yeah, they're so excited. You know the difference between an 18-year-old with a 1U server and a 30-year-old with a 1U server is basically one of them pays the electricity bills. You spin up a multi-socket Xeon 1U server with that jet of a fan system in there, and you're gonna be burning like $50 to $100 a month in electricity. You can burn a lot of electricity. And so I'll get to you in a second, John. And so basically, you got this whole rack of servers, or you got 20. You got 20 servers that can theoretically be burning $50 a month on electricity. That's a lot of money. So, what you can do with load balancing is what if we can move these instances around as load matters, right? So let's say we have the Active Directory server up here, an FTP server up here, let's say a marketing server up here, the whole 9 yards, right? And so basically it's midnight, right? The moon is up. The moon is up. It's midnight. You don't need to be burning a lot of electricity. Essentially, put all these other servers, put 19 servers into a low power mode so you're not burning electricity when nobody's using the damn things, right? And all of your instances are up here in this thing, right? Well, let's say it's 8 o'clock in the morning. You have users that start coming in the office. And so when they start coming in the office, they start logging in their computers. And so when they log into their computers, they're going to be hitting Active Directory. This is what deals with, usernames and passwords and credentials and all that kind of stuff, right? So you have lots and lots of users that are now hitting Active Directory. Active Directory now needs, that server needs a lot of hardware resources. So what we can do is we can simply move this to another physical server. Basically spin that up, put that into normal power mode, so that all the users are now hitting that Active Directory server as they're logged in and doing stuff throughout the day. Basically, this is registering how many resources the server needs, and then after everybody logs in the morning, then it can just go back to the first hypervisor server and just sit there until after lunch when everybody starts logging in again, and then it can move, right? So now you're powering up and basically powering down these physical servers based off of the load that's currently hitting them, right? Again, let's say, if you have a web server here, the marketing department does some campaign. Normally you don't get very much traffic, so the web server is just doing its thing. All of a sudden you get lots and lots and lots and lots of people coming in. It can be moved to a different hypervisor server that might have more resources to it, and then all those users are being directed to that. All those hardware resources can be used in order to provide whatever the end users need, and that's basically the idea with things like load balancing and failover. And this is just, again, it's one of the amazing things in the modern world of cloud computing where it just does it. You just sip your cup of coffee looking at log files. That's a beautiful way to do work. And again, this is why I also find it weird when people get really snarky about cloud computing. Like, people get snarky about cloud computing. And I'm like, no, but how can you hate this? Look, I'm a snarky bastard. But seriously, how do you hate this? I don't understand. Oh, let's see here. Oh, Jock was asking something. Jock, did you get your question answered?
So basically, I'm getting an understanding of this. So if I have my rent stuff from Amazon, I get a cloud services, and I'm in an area, and I get them to run up my instance. I do all the things, the configuration. Something happens, and say for instance, like I'm in California and there's an earthquake. Something happens. Basically, they would take down all the instances that's running close to here, transfer them to another server, maybe on the East Coast, to be able to until everything is repaired, then send them back. Is that kind of like the same thing you're saying here?
Well, theoretically, they could do that. They could do that. They're not going to do that. So, like, when you start looking at this, like AWS, we'll talk about this in a second, is, again, their infrastructure is huge. Their infrastructure is absolutely huge, right? So you got the United States. There you go. See, I'm a teacher. Look at me. I draw like teachers. Anyways, so let's say they have their data center here in Seattle. The big thing to understand with how AWS does things, again, because they are so massive, is they divide things into regions. And don't ask me exactly what the regions look like in the United States. Just go with the concept of region. So here's the deal. So with like these instances, if you're dealing with Amazon, basically what would happen is, let's say they have one data center here and one data center here, and basically what they want to do is they're like, okay, we want to take this data center down because we're going to do upgrades. So what they could do is locally, they basically move all those instances in a time-consuming, god-awful process. They will move over to the other data center. So basically, in the Amazon world, that's kind of how it would work. So if they're constantly, they're pulling servers out of production, putting them into production, and when they do that, all these little instances are running around. But they divide things by region. And so this is the important thing. Again, if you're going to be building out this kind of infrastructure, if you go to Amazon, what they tell you is they tell you to literally purchase duplicate resources across multiple regions. So what they'll say is design your infrastructure in one region and design infrastructure in another region. You have to configure the replication strategy so that if this entire region goes down for some reason, again, I don't know, power supply goes out, something like that, then you'll be up and running. Basically with AWS, more or less, all they say is if you don't set any of this crap up, what they say is if they go down, then they'll be down for as long as they're down, and then when they come back up, you should be in the same state you were in when everything went down. So if they go down for a day, so this happened in like the East Coast region a while ago, I think Netflix was affected. And basically, yeah, Amazon was just like, yep, we told you to replicate across regions, you didn't do it, so we don't care. So yeah, that's, once you start dealing with like Amazon's the world and Azure, again, it goes into that whole architecture and design, that type of thing. That kind of
is that just building redundancies?
Yeah, for you, that's where you're going to need to, when you design your architecture, and you need, again, much more complicated in this particular class, that's where you have to design. You know, again, what happens if AWS goes down? Are you a company that can afford to spend $10,000 a month on a replicated infrastructure on the off chance there's a failure? Or do you just ride out a day of being down because you don't have $10,000 a month? That's, you know, between you and your boss and your investors.
Okay, yep. Thank you.
Yep. Okay, so let's see here. So we started talking about this with virtualizations and hypervisors. Basically, you got two types of hypervisors. You have a type 1 hypervisor and a type 2 hypervisor. So type 1 hypervisor is going to be what's called the bare metal hypervisor. So basically, think about this as an operating system onto itself that does essentially one thing and one thing very well, and that's be a hypervisor, right? So essentially, again, you have your server, You install a type 1 hypervisor onto that, and then within that, you can basically run instances of virtual machines. And this is where you can do that really fancy stuff. Basically, you can have a whole rack with failover and load balancing and the whole 9 yards, and basically be able to move these instances between these different physical machines. So each physical machine will have the hypervisor installed onto it. So with VMware, it used to be called, was it vSphere? Or no, ESXi? So many words. I think it used to be called ESXi. I think so. So ESXi, as I recall, was the type 1 hypervisor. You would install that onto the physical servers, and then you could run the virtual machines. The thing with it, though, is on top of the type 1 hypervisor, you also needed a way to manage these systems, again, for that high availability or whatever. And that's where they had something called vSphere, at least back in the day, and that was management software. So essentially what would happen is you install the type 1 hypervisor onto the physical machines that are going to be doing the virtualization. Then you would install vSphere onto your system, where you would then manage this cluster of virtual machines. That's basically what it is. It's all, relatively simple. The thing that will get you into trouble with this, there's something called open source washing. So it's interesting. Be careful with open source. Open source is a dangerous thing in the modern world. I just went through this conference called All Things Open. I got a new view of some modern open source. So one of the issues you can run into with open source is companies can open source parts of a system, but then have other parts of the system not be open source. So at least how it was ESXi, so this type 1 hypervisor. They were very proud that it was open source. This is open source, this is production ready, at least it was, I don't know what the license currently is. You can literally download this, like Microsoft could download ESXi, put it onto 100,000 of their physical machines, and away you go. Well, here's the thing. You needed vSphere to manage ESXi. vSphere was not open source. So ESXi, the type 1 hypervisor, free. vSphere was $3,000, or about $1,000 per license. So it's like one of those weird things, and one of those things you kind of think about. So actually installing ESXi is free, and theoretically there is a way to manage these systems sort of without something like vSphere. But if you wanted vSphere, you want all the fancy features. Basically, every server that vSphere managed would cost you $1,000. So that, my friends, is how a free piece of software ends up costing you $1,000 per machine. And that's one of the things you do have to be careful about. So that's basically all a type 1 hypervisor is. So when you install this, there is no solitaire on the machine. There is no Windows on the machine. There is no internet on the machine. All a type 1 hypervisor is an operating system that allows you to run these virtual machines. Very good for infrastructure. Then you get to what's called type 2 hypervisors, which you will probably use more often. And basically when we talk about type 2 hypervisors, these are things like VirtualBox. So you probably have heard of VirtualBox. What a type 2 hypervisor allows you to do is it allows you, so you have your computer with Mac, Windows, Linux, whatever else onto it. You then install a type 2 hypervisor onto the machine, and basically you get a nice little GUI environment. So again, whether it's VMware, used to be Fusion, I guess it's now Workstation, Parallels is one, again, VirtualBox is one. Basically you install that software onto a full-fledged operating system, and then what you're able to do is you're then able to create virtual machines and spin them up within that environment. And so the nice thing there is you don't need the management software. You can just sit there and you can play around with the server and you can configure everything. For the most part, when you do that, the computer that you create, the server that you create, is logically a server like any other server on the network. So you do have to configure it properly. We may have a class on that in the future. But basically, if you configure the networking properly and you do things how you're supposed to, you could literally create a server that is running on your system, and you get a lot of that virtualization functionality. So a lot of developers will use that. So like a lot of developers like Macs, again, I got a pile of them. Macs are great computers because they do what they're supposed to do. But let's say you have a Mac, but you need a code for Windows. right? You need to see if it works on a Windows machine. So what you can do is you can have Parallels or VirtualBox or VMware, one of the VMware products. You can install that. Within the instance, you can then install either a Windows Server or Windows desktop operating system. And basically when you write your code, you can then just put it into that instance, and then you can run it on that virtual machine and see if it does what the hell it's supposed to do. Type 2 hypervisors used to be a lot more useful. Again, if you go back about 10, 15 years ago, Microsoft had a lot more proprietary crap. There used to be things called ActiveX controls on web browsers. Basically, there's its own proprietary way of dealing with some stuff in the internet world that nobody else could use. So we had a lot of clients, and what they would do is they would use a virtual machine within their Mac to have Windows so that they could open a website that had an ActiveX control. So that's the kind of stuff that you can do with, you can do with a Type 2 hypervisor. Yep. Let's see here, with the hypervisor configurations, with modern ones, this should be better, but you do have to be careful, because a lot of times when you're creating these virtual machines, you have to set what resources these virtual machines will use, right? So you have your host computer, whether it's a Type 1 or a Type 2 machine, and you'll have so much RAM, right? You'll have a CPU, and then you'll have RAM. Let's say you have 32 gigs of RAM in the modern world, and then you have a hard drive and the whole 9 yards. One of the things that used to cause a lot of problems you have to be careful about is if you over allocate RAM to your virtual machines. So let's say I have this box and I want to run a number of virtual machines. Let's say I want to run 5 virtual machines. And I want to spin them up all at the same time. So when I configure this, remember, I've got 32 gigs of RAM total. And one of the big things to remember is that your host machine is a machine too. So you have to make sure your host machine has enough RAM to do whatever the hell it's supposed to be doing. And so you're like, okay, well, I've got 32 gigs of RAM. Let's make sure my host machine, keeps 8 gigs of RAM, make sure with overhead or whatever else. So then, if you're looking at that, that takes you down to 24 gigs of RAM. You got 1, 2, 3, 4, 5 virtual machines here. Then you've got to start thinking about how much RAM do these virtual machines need. Again, if you've got 5, you can't give them all 5 gigs of RAM each because you've only got 24 gigs. So that's where you got to start thinking, like, well, this FTP server, that probably only needs 2 gigs of RAM. Right? And this web server, we'll give it 4 gigs of RAM. And this AI server, crap, we need 10 gigs of RAM. Right, so if we're up to 16, so if we're up to 16, that means I've only got 8 gigs left. Okay, let's do 4 and 4. And so you can run into some weird bottleneck issues when you're configuring your virtual machines, where if you over allocate resources to these virtual machines and there's not enough on the host system, things can go wonky. Or again, like I say, if you over allocate, because theoretically, like when you do these configurations, you could leave. You could end up leaving your host machine 2 gigs of RAM. So modern operating systems. What do you think is going to happen if you spin up all these instances and there's only 2 gigs of RAM left for that host machine? Things are probably going to get, as I say, quirky. And this is one of the problems you get into in the virtualized world, where things don't necessarily fail. Again, hard fail is good because a hard fail means something something failed. Quirky, soft fail is, it doesn't seem like it's working right. And this is one of those times you can very much get the, it's working, but I don't know. Oh, what was vSphere? vSphere was the management software that allowed you to control ESXi hypervisors from the VM world. Jock again.
So, a few weeks ago you said that when we were using how to bring up an actual working website using a possible Mac as a server.
Yep.
And so this is an example of that. Now, if we have a older Mac, like you said, like a 2012, 2013, and we're going to use as a server, and we have an example, you have there 32 gigs of RAM. You mentioned before how AWS and other things use load balancing. Couldn't we just put in Python's code to load balance those different containers to be able to see which one spins up the most to transfer RAM between those 5 instances? I don't know if this is you understand the question I'm asking, or is that just?
Yeah, I would say you're going a bit far afield with that. Again, like with any of this kind of stuff, we all most likely can configure something. Do you want to spend 100 hours doing it? So that's what like yeah, with some of this stuff, like yes, could you roll your own God help you solution? Maybe. You don't want to though. Buy a product. Buy a product.
Copy. Thank you.
Okay. Beyond that, when we talk about the virtualization world, we then also there's these things called containers, Linux containers. These become more and more popular, especially in the coding world, and it really makes me scared. Really makes me scared. So, when we talk about virtualization, again, you're basically creating these instances. You're doing resource allocation and their own bubble, right? And then you got the host machine going on around them. With containers, it's actually kind of cool how they do it. But basically, it's like you're siloing off your environment. It's virtual. Again, this is where we talk about virtualization. When we say the word virtualization, what that actually means in the modern world, right? You've got virtual machines for computer virtualization. You have containers, which is kind of a Linux virtualization. You have virtual hosts in the web hosting world, the web server world. You have virtual environments in the Python world. We use the word virtual a lot. It means different things. Basically, the idea with virtual is that you're containerizing something. So anyways, when you're dealing with containers, basically you have your Linux box, right? So you have your Linux machine. And this might actually be an instance. Again, we start talking about operating systems. Again, we talk about architecture. You can make some very complicated stuff. So let's just say this is an OS and it's going to be Ubuntu. Basically with this, right? You've got the operating system down here, you've got the resources, you have your RAM, you got your CPU and that kind of thing. And essentially with containers, what you do, I don't know how to visualize this better, but basically you kind of silo your containers and then they're all able to use the resources that are down here. So let's say I want to make this my web server. So I configure this. So I can set this up, and I can set this up with its own IP address and all that kind of thing. And I set up, Apache in here, and I set up, whatever, my index files and all that kind of stuff. And this becomes a container for this particular web app. Then right beside it, I can have a different web app. But with this one, I want to use Nginx, and I do configurations and all that kind of stuff. And over here, let's do a SQL, and there's configurations. And so basically the idea is I'm kind of containing these containers in their own silo. Again, this basically essentially turns into a type of file that can be moved. The difference here is that these are much more connected down to the hardware layer. So you don't have to allocate RAM quite the same way you do have to in like virtual machines and that type of thing. And so that's one of the reasons that this is a little nicer in the programming world. What a lot of programmers are now doing, for good or for horribly bad, is basically they're creating their own containers. So when they create their web app, not only are they creating their web app, but they're creating the container with all the configurations and everything in there. And then basically they send this to the administrator to put into the infrastructure and spin up. So that's like with a lot of DigitalOcean. I know coders now that'll use DigitalOcean for actually putting stuff into production. And so what they do is they'll create a container on their local machine. They'll configure everything. They'll make sure the web app is working properly, the whole 9 yards. And what they do is they take this entire container and essentially upload that onto a droplet in DigitalOcean. And at that point, it basically should just work. Maybe a couple of different configurations have to be put in there, but it's not the same thing. It's not like if I was going to create like a WordPress site, it's not like I create the WordPress site on my computer, so I install everything on my computer, I configure it all on my computer, I make sure it all works, and then I go to the server, and then I install WordPress, and I install my SQL, I do everything up there, and then I migrate the files from my thing up there. Basically with containers, the idea is that you can basically move this entire container around wherever you need it to go. And that will be its own class going into the future. Then we get to the AASs, the as-a-service model. Again, a lot of people are horrified by the as-a-service model. Is what it is. Basically, it means that you only maintain the resources that there is a need for you to maintain. Outlook used to be installed in every computer and would connect to an Exchange server that would have to be installed and maintained. Now you simply pay for Office 365 or Google Apps. And so basically, when we start looking at the IaaS model, one of the questions that has to be asked is, how much of this do you really got to own? How much of this do you really have to own? Again, when we talk about the modern world of being a CIO or a CTO, I had a buddy of mine, and he was talking about where a CFO just big smacked a CTO about 8 years ago. It wasn't a short time ago at this point, right? And basically that was the thing. So the CTO, the CIO or whatever, went to the CFO and said, hey, I need $50,000 for our Exchange server, for the new Exchange server, and plus more money to get installed or whatever. So you do have it. So Exchange server is an email server, especially in a real company. There's a whole bunch of stuff with it, expensive hardware, the whole 9 yards. And the CFO just looked at him and said, no. And then the CIO was like, what do you mean no? And he's just like, no. He's like, look, I looked at Office 365 for $10 a month. All of our users get access to all of the Microsoft software. And because it's $10 a month, since we're not buying any hardware, we can write all of that off every year or every quarter. Ergo, you're not getting an Exchange server. And again, that's going to be one of the big questions that you really need to be thinking, again, as a decision maker, as a professional in your environment, how much of this crap do you really want to own? Again, in 2024, do you still want to run your own damn email servers? And again, a lot of people, especially a lot of young people, no, they think that would be absolutely stupid. Well, if running your own email servers is absolutely stupid, what else is also absolutely stupid? And that's the thing you need to start thinking about, this whole as a service model is, how much of this kind of crap do you really need to own? Things to think about, again, when you're doing with the as a service model and you start talking about things like cost, is, again, and this is where you need to be thinking about things as a decision maker, right? You may be 18 years old right now, but remember, Mark Zuckerberg frickin' started Facebook in a college dorm. You can be a decision maker really quick. And decision makers is not just worried about distros and configurations, it's also worried about things like taxes. One of the interesting things is when you buy hardware, right, that's a fixed asset. Oh, and fixed assets have things called depreciation schedules. And then you just start crying. And then you start talking to your accountant and your brain starts hurting. And you're like, can I go back to my servers, please? So if you buy $50,000 in hardware, you can't write off $50,000 in hardware in 1 year. You have to, it's a depreciating assets, you're able to write it off over like a 3-year, what's called a schedule. And there's a whole bunch of stuff that goes into it. So again, for your company, you have to outlay $50,000, $100,000 in hardware. Actually being able to deduct it from your taxes may take the length of time. It's a whole big Megillah. Again, if you simply basically have a subscription to an as-a-service model, you are not buying a server, you're simply paying a monthly fee for a server, you're actually able to deduct that off of your taxes every year. You don't have to worry about getting taxed by the state because you don't own the hardware. Again, anything that you own, your state might tax you for. You don't have to worry about depreciation schedules, you don't have to worry about a lot of that kind of stuff. So that's one of the nice things with the IaaS world. The other thing to be thinking about, again, when we start talking about cost, again, I talk about things like Office 365, costing you $10 a month, and a lot of noobs, a lot of 18-year-olds lose their mind. Why would I have to spend $10 a month? I can spin up my own Linux Pigeon server for like $20, and that'll save us a lot of money. One of the things to think about, even if you have like 1,000 users. So 1,000 users, I'm not even sure that's considered a mid-sized company anymore. Anyways, 1,000 users, $10 a month, that comes out to $10,000 per year. So that's 1,000 users that are getting access to software that requires almost no administration and maintenance. Basically, you can just hand it to a secretary and you can say, create whatever accounts need to be created, done, right? Again, if you hire a tech professional, especially, right? If you hire a tech professional, especially when you start talking about things like benefits, healthcare, 401ks, that kind of stuff, that can run you up, well over $100,000 a year very easily for one tech professional. So you think about it, 1,000 users, how much support what 1,000 users need for an Exchange server setup and installing everything locally, again, versus just renting off of an as a service model. That's one of the things you really need to think about. And I'm telling you, these numbers are nice. Christopher, what's up, Christopher?
My question was, how do you differentiate between understanding, I guess, the security versus I had my I guess between the security and I can't think of my question now. Now I feel like an idiot.
No worries. The security and what the stability, reliability. Is that what you're looking at?
Yeah, I guess on people's content or whatever you're storing on servers. That makes sense. The data. That's what I meant.
Security versus the safety, the encryption or whatever, the data itself.
Mm-hmm.
Yeah, so it depends on what. Again, we start talking about all of these models. It depends on what you're buying. So again, we'll talk about that a little bit later with things like compliance. So again, basically when we start looking at this, one of the things that makes me sad is this goes from being a technical job to just fucking specking out shit. Like, what do you buy? You're like a kid in a candy store. Which one do you want to buy? And so when I talk about this kind of thing, or especially when we talk about AWS or Azure or DigitalOcean, we have to understand is they're offering products that are based off this technology. But the product that they sell is going to be different. It's like I'm explaining to you how cars work, and then whether you buy a Volvo or a Tesla or a Yugo, those are all cars. But you got to decide is cost more important to you or is safety? Right. And so that's the thing things like with data security, so there's compliance, GDPR, PCI, HIPAA compliance. These are real, serious. And so there will be vendors that will be compliant up to certain standards. And so that's where you've got to look and say, okay, this is compliant to the standard, so I feel more comfortable about it. But I do have to say, again, with the security and the safety, a lot of this comes down to trust. Again, I was surprised. I wish I had the newspaper article for it. But Azure got bitch slapped 6 months ago, and that's Microsoft. So you do have to be concerned about it.
And I guess you have to, understand the differences between whether you work with some of these companies or you actually have your own hardware. I mean, I guess in trying to understand, I guess you would have to look at what you're doing and understand the end result of what you're trying to do, whether you should buy hardware and store it, let's say on a server that you own or, rent out a server.
Yeah, and that'll be, again, it'll be things like cost, again, it'll be regulations. So, again, I'm now in Nashville, I came from the Baltimore area. And so, again, one of the concerning things, you have all these founders who want to spin up their own servers in their apartment. If some jackass comes into your apartment and steals your damn server because it's a computer, right, if that has personally identifiable information on it, that can be bad. Again, most of these startups are so small, people don't get sued over it, but if it is big enough, that could be a real issue. And so, yeah, that's where you have to look at, again, like I say, with the compliance. So we start talking about PCI and HIPAA and that kind of thing. There's things like, are the servers physically secure? So is there a lock between the server and the rest of the environment? Are there environmental controls? Are there sprinklers or the equivalent of fire suppression? And does that go off if there's a fire? There's a whole bunch of that. And that's where you gotta be careful. Yep.
Okay. Thank you.
Yep. And that's the other thing too. You got to figure with configurations. And again, I talked about this in cybersecurity. You are the most dangerous person. So there was a startup. God, time goes by. Probably 5 years ago. Feels like last year. Probably 5 years ago. It was a startup. It was actually doing really well. And then they had left open on AWS, somehow they left their buckets, the security on their storage buckets open. And so basically these hackers went in, true story, hackers went in, not only did they wipe out their platform, they also deleted the damn backups. Because their platform backed up into a different bucket. And so when the hackers got in, they're just like, that's gone. Man. And so, yeah, and that's like that's the kind of thing. Like if you build your own, you're most likely going to be less vulnerable to that type of attack. But you are more vulnerable to a crackhead stealing your server. You know. Yep. Make sense?
Mm-hmm. Thank you.
Cool. Yep. So let's see here. Yeah, so that's where you got cost. Yeah, here we go. Talking about things like security. Hey, as a service security. Yep. It's a concern. As I talk about, most of your job is going to be on the whiteboard. Again, all the 18-year-olds out there, almost any profession you get into, you're going to think it's all like running and gunning, doing all this cool, sexy stuff with computers, and you're going to find out 90% of your job is paperwork. Well, basically, this is our version of paperwork. What you do with security is, again, you sit down with all the interested parties. You sit down with your damn legal department. You sit down and you talk to everybody and figure out what actually needs to happen. You need to figure out what resources you actually have. Again, whether it's institutional, whether it's knowledge resources in the company, or whether it's just pure money. Either one works. And again, with that, you design the security environment based off of all of that kind of stuff. And let's see here. We start talking about as a service. There's a lot of different as a services in the modern world. So there's software as a service. Basically, this is a full-fledged product such as Office 365, Adobe Online, or Salesforce. Right? Swipe your credit card, $50 a month, $25 a month, whatever else, and you get access to this particular product. I know a lot of old school folks really hate this. I have no idea why. I had to deal with it called COAs. Oh, those licenses back in the day. That was nasty, right? Outlook will get corrupted, and so all you'd have to do is reinstall Outlook. And then you're like, yeah, fine, where's the license for Outlook at? I don't know. No, seriously, we need the license. I don't know where it is. No, I can't reinstall Outlook until I've got the damn license. Where is the license? That's a real thing. Again, that's one of the things that makes software as a service so nice, is basically if your entire computer gets stolen, so your user leaves their fancy computer in the car, some crackhead steals it, basically you hand them a new computer, you tell them to log into the websites, and away you go. That makes life really, 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 really easy. Then there's something called platform as a service. So platform as a service was a Heroku, I think, in the modern world. Basically what a platform as a service is think about a server that's more or less configured to do what you need it to do. So you don't get a lot of fancy configurations. You don't get a lot of stuff, but it does basically what you need to do. So think about like GoDaddy or any kind of shared hosting platform. Right, so when we talk about PaaS, platform as a service, basically it's the hosting, right? So you go and it's got a web server on there, so it's got Apache. You'll be able to futz with a couple of configurations on it. It'll have something like PHP on there. Basically, it'll have MySQL generally on there for a database, and it'll have some other stuff. So basically, the thing is, what you do is you write your code so that it will work within this environment. You then upload your code into that environment, and hopefully you're fine. Hopefully you're fine. Right? You don't have to worry about CPU fans, you don't have to worry about operating system updates, you don't have to worry about anything. You literally just upload your code and away you go. The thing that you have to worry about if you look for platforms as a service is whether or not it actually supports what you need it to support. That's a big deal, right? So again, with these hosting platforms, they'll deal with things like PHP or MySQL, that type of thing. But again, if you're going to be writing code in Python, one of the things you have to see is whether the PaaS, the platform as a service, actually supports Python. Not only do you have to worry about does it support Python, but does it support the frameworks that you may be using, right? So we use Bottle a lot for a lot of our hands-on classes for creating web apps. So if you're going to use a platform as a service, not only does it need to be able to use Python, but you're actually going to have to be able to use Bottle. And again, with other connections and everything else, you do have to make sure those connections will actually work. So platform as a service can be great, can be very cost effective, but you don't get a lot of configurations with it. Let's see here. IaaS. This is what you start talking about with things like AWS or Azure, right? So we talk about Amazon Web Services, or we talk about Microsoft Azure, and we talk about IaaS. And this is really where we get into that whole abstraction world. So basically with AWS or as Azure, you can go in and you can buy whatever infrastructure that you want. And they've got so much. They have so much. I remember back in the day when they had like compute, and they had storage, and they had database. They had like 5 things. I remember back in like 2008. Now you go to AWS or Azure, and it's like going to like the spice section in the grocery store and figuring out what spice you need. There's like 300 different things. Even with databases now, if you go and you take a look at how many databases that AWS offers, you're like, I don't, fuck, so many, just so many. But the nice part about this is again, if you're a high level professional, you really want to make sure that your platform, your project is going to be able to run, as fast as possible, right? So your project select statements in the database matter, or in your project insert into the statements in the database matter, right? You can go in and you can pick the exact database type with the exact performance that you need with CPUs or whatever else, so it's incredibly optimized for whatever you're doing. So you can come in here, again, with IaaS, and this is where you can pick, your compute. That compute, you can then get storage buckets. Again, there's lots of different storage at this point, and you can decide what kind of storage you want. I'm going to screw this up because there's too many. Is it S3? Ease compute? I forget. Anyways, I think it's S3. I think it's S3 storage buckets. So S3 storage buckets, kind of like the normal storage bucket. Now then you can use something called Glacier. So what Glacier is nice is it's incredibly cheap. It's a fraction of cost. It's like a tenth of the cost like S3, but it's really slow. So you can upload to Glacier, but if you actually want your data back, you literally put in a request and you literally wait half a day to get it. But again, think about this. If you're creating a backup system, right? So if I'm creating a server that needs to provide services to users, I'll get an S3 bucket, or I might get a higher performance bucket. On the other hand, what if I'm creating a system to do off-site backups? I'm not going to access that data very often. Again, the only time I'm really going to access that data is if there's a complete and utter failure. So why spend the money on S3 when I can purchase Glacier for a tenth of the cost? And that's the cool thing with IaaS is you go in there and you purchase exactly what you need. They have networking services, so there's, what's the word for it? It's virtual networking, so it's not VPN, it's virtual networking, so that you can actually create networks within their infrastructure and basically like firewall rules and that type of thing. So like within their own infrastructure, again with IaaS, you can essentially create your servers with your buckets and your other configurations, and then you can set who is allowed to talk with who and who's allowed to talk to the outside world. And a lot of cool stuff with this. Again, with this, absolutely great, absolutely phenomenal, but you really got to know what the hell you're doing. Like, you have to understand what you're building. The story that I always have with AWS, again, back in 2008, 2009, back when I had my business, that was when AWS originally came out. And I literally remember sitting down with my web developer at my company, and we're looking at it, we're like, wow, this is cool. And I was talking to him, I'm like, yeah, I don't understand. Where's the FTP connection? How do I FTP files up to an S3 bucket? Because we didn't understand how that worked. And so that's the thing. It's really powerful if you understand what the hell's going on. Let's see here. And then when you start talking about ASs too, there's Metal as a service. And so Metal as a service is interesting now, or it used to be a lot more interesting. Again, things have gotten better. One of the things you have to remember about the technology world is things get better. What was amazing 10 years ago is fine now. The cool thing with Metal as a service, well, you're talking about those Type 1 hypervisors before, right? The Type 1 hypervisor where you could, install your instances. Basically, it's kind of Metal as a service is kind of like a version of that, where essentially what you're able to do is companies literally would have physical hardware. So they would have physical servers that you could rent. right? And so this was a quad-core CPU. It had 32 gigs of RAM. It had two 250 gig SSD drives set up in a RAID 1, whatever else, right? So basically there is a physical server sitting up in their data center. And the cool thing with Metal as a Service, what you're able to do is you basically had an ISO file, and you could upload an ISO file that would get installed onto this physical hardware, and then you got bare metal performance. So again, go back 10 years, virtual machines weren't as good as they are now, right? They worked fine. They were fine, but they weren't great. So if you actually needed good performance, you wanted that bare metal experience, and so that's what Metal as a Service allowed you to do. I used some shared hosting provider, I forget what they're called, back in the day to do Metal as a Service. IBM, they used to have something called SoftLayer. I think it's called SoftLayer. I don't know if they still exist anymore. And so that was really useful. So again, that was the thing. It's like, so you could have this thing up in the cloud, up in somebody else's data center, and you got the performance of that bare metal operating system. If you did anything stupid, that was up to you. And again, that was one of the problems that I ran into. So I had, and again, so whatever company I was using, unmetered. Anyways, they had horrible documentation. So literally, I was renting that physical box, that Metal as a Service. I did a reboot. When I did the reboot, it was mirrored drives. One of the mirrored drives physically failed. The problem was their documentation was so garbage, I couldn't figure out how to get the damn thing back up and running properly. And that was the thing, right? Mirrored drives. Well, if one RAID drive fails, you're just using the other one. Yeah, well, if the documentation is right and the hardware works how it's supposed to. And so literally, I got into a snit with this company because I said, well, we've already swapped the physical drive. So if you can't figure out how to rebuild the array. If you can't figure out how to rebuild the array, just wipe and reload the system and start from square one. And I was like, but that's not the point of having a RAID. The point of having a RAID is that I don't have to wipe and reload the system. And then it went badly. So again, that's one of the things about Metal as a Service is, if your RAID fails, have fun. I hate RAID. Have I told you how much I hate RAID? I really hate RAID. So we're talking about things like infrastructure as a service. Again, we got AWS and we got Azure. Those are big infrastructure as a service plays. There is also Google App Engine, I guess it's called. I've met one person who uses it. I was at the All Things Open conference and I met a founder and he uses Google App Engine. One. I don't know what it is. It is really weird with Google. Again, Google being Google, they have their own infrastructure as a service play, and I know damn near nobody who uses it. Most of the time it's going to be AWS and Azure. The big thing that you're going to be dealing with, again, if you're dealing with AWS and Azure, is they have so many products at this point. If you start using this platform, you become more of, a salesperson or whatever, really, than a tech professional. That's where like AWS reInvent is coming up. And so if you are going to start getting married to one of these platforms, go to events like AWS reInvent or whatever the hell Microsoft, is it Build? Microsoft has a version. And you want to go there simply because they can show you all of these different products and what these products do. And you can literally figure out what the hell product you need for whatever it is you're going to be doing. When you're choosing between something like AWS and Azure, one of the big things to be thinking about is what is your tech stack. So the tech stack is all the technology that's required to actually make your project useful. So again, if you're in the Microsoft world, so if you're an old school enterprise, if you're an old school government, if you have a legacy Microsoft environment, just use Azure. Azure is Microsoft's infrastructure as a service play. And it's just going to work well with your Microsoft environment. Look, you already married Microsoft. The whole question about whether or not you should tie the knot to this particular company was answered long before you were probably even born. Back in 2000, back when I got my NCSE, is when somebody made the decision to get married to Microsoft. You're stuck with it now. Now is not the time for stupid arguments. So if you're dealing with Microsoft, you're probably going to go with Azure, because Azure, again, Active Directory, all those Microsoft products really are well integrated because obviously it's their system. If you're more in, again, the modern startup world, you're dealing with Linux. Again, it's that modern architecture environment of microservices and service-oriented architecture. You're doing Linux, that kind of thing. You might want to go with AWS because that might actually be better for you. But look at the two and play around with the two and figure out which one you're going to be using, because at the end of the day, you are probably going to get married to one or the other. Take a look at something like DigitalOcean or Linode. For a lot of you folks, I would actually argue DigitalOcean and Linode are going to be the way to go, simply because they're so much simpler. They don't offer 250 damn options. At this point, there's still getting to be too many, but you're dealing with like 30 options instead of hundreds of options, right? DigitalOcean, their thing is droplets. So an instance of an operating system is a droplet. So you literally go there and you're like, what droplet do I want? I want a CentOS droplet. I want an Ubuntu droplet. I don't know, they got a whole bunch of different things. You decide which droplet you want. You decide what region you want it to be in. You decide the resources and you install droplet. And away you go. If you want storage services, they offer additional storage services. If you want database services, which is actually really interesting, instead of running your own database server, you can just connect to a database service and you don't have to worry about a lot of stuff, right? So they have a lot of that infrastructure as a service environment, basically in a much more simplified fashion, which is the way that you might want to go. And again, you start talking about 2024, both DigitalOcean and Linode, they should be they're as stable as any other company out there. Again, if you go back 10 years ago, I don't know if we want to use DigitalOcean. It's 2024, they should be fine. We keep talking about things like in the virtual cloud computing world. The next thing to talk about is clustering. So this is going to be big, especially for database servers. So you talk about virtualization, all of that kind of stuff. There's a lot of overhead there. There's a lot of configurations. One of the things you can do is clusters. Again, normally with databases. What clusters are is generally where you have physical servers. Theoretically, you can make these virtual servers, but that creates a whole different level of complexity, right? So let's say we have a database cluster. Let's say we have a MySQL cluster. And the idea is you have these database servers, and these database servers are able to communicate with each other. There's something called a replication strategy, and so they will replicate their data to the other servers as there's different changes, and you set up those configurations. The idea being is if you have a user, and he needs the database service. He needs to do an insert, he needs to do a select, he needs to do a SQL statement. Basically, he is just connecting to the cluster and not necessarily logically to any one particular computer. As he comes into this cluster, basically the system will then auto-route him, or the person, to whatever server is most appropriate, right? So when you create one of these clusters, again, things for load balancing, if you have lots and lots of users coming in, it can load balance to different servers in the cluster. If a server in the cluster fails, basically that server is just automatically taken out of the cluster, and so people are rerouted to different boxes. But basically, this is all set up within the software itself, right? So basically, each one of these, you actually have a physical box generally. On that physical box, you have the operating system. Installed onto that operating system, you have MySQL or whatever the software is. And with that, there is a whole bunch of configurations. And so basically, you replicate that. And what happens is all of these different boxes are communicating with each other in whatever manner. And so you get load balancing or whatever else. Again, the nice part about this with the cloud environment is you don't really know, nor do you care which physical machine you're touching. All you care about is, are you getting the services that you requested in a timely manner. So that's all there is with clustering. Again, the big thing with clustering is that's got to be built into the software. Again, if you go to the Microsoft world and Active Directory, when you create Active Directory servers and you put them into the domain, they will start doing all of this kind of stuff, this clustering thing, when you set it up. Then beyond that, you have things, application servers. Application servers aren't as big nowadays as they were about 10 years ago, but you may still run into application servers. Basically, it's kind of sort of like a modern version of a mainframe. And so you run into this when you're dealing with especially legacy software, or maybe highly customized software that has to be installed onto a particular computer, right? So let's say you're a user and you need to use a piece of software, but you want it on the cloud. But there is no cloud version of it, right? They didn't build a cloud version of it. They don't want to build a cloud version of it. They may not even be in business anymore. So basically what you can do is you can create what's called an application server. The application server is going to be a box that's going to be sitting somewhere. It has an OS on it, and then you basically install this application server software on there. It might actually be built into Windows. Windows has an application server component. Lots of different stuff do. And so basically what you do is in this environment, you're then able to install this legacy application. All right, legacy application and any other type of thing. You may have also heard of VDI, Virtual Desktop Infrastructure. That's basically an application server environment. And so then what happens is the user can then use what's called a thin client. So a thin client, it can be just a piece of software installed on your computer. It can be a small little computer type device. And basically what that thin client does is all it does is it connects to the application server and then essentially sends a video feed from the application server to your computer. Right? So your computer, you're seeing a video feed from the application server. It captures your keyboard and your mouse strokes, sends those to the application server. The application server is running that environment, and then basically gives you a window into the application server so you see what's going on. Application servers were big for us back in the day with QuickBooks. So QuickBooks is better now, but again, you go back QuickBooks 15 years ago, there was one online version that was pretty crappy, and then if you wanted any of the custom QuickBooks versions, those you actually had to install onto your computer. Again, you had accountants, they wanted to be working in the cloud world, and so what we would do is you would either go to a vendor that offered this, or you would set up an application server, and essentially you would install QuickBooks into the application server, and so basically they could then go and QuickBooks is actually running on the application server and then essentially sending them a video feed so they can see what's going on. So think about this as like infrastructure, again, a remote desktop, if you're used to a remote desktop or VNC or anything like that. Basically imagine what you're connecting to is basically a session in that server that allows you to interact with the software as you want it. Let's see here. We get to serverless architecture. I like serverless architecture. I think Citrix offered something like this. Yeah, they probably did. Is Citrix still around? I'm getting confused. I need to go out and figure out what companies still exist anymore. The next thing is serverless architecture. Look, boys and girls, everything uses a server. I get it. That's not what we're talking about. Oh my God. You ever had one of those days you're just getting a headache? I was talking with like a real tech professional, like a real executive level tech professional a couple years ago. And I was saying I was so excited about serverless architecture because it's really cool. It's really cool. And then this executive got very snotty because, well, I mean, nothing's really serverless. Everything's running on a server. It's just like, oh man, you're just killing it for me, man. You're just, God damn it. That's not what we're talking about. Anyways, so to be clear, when we talk about serverless architecture, we're not talking about running VPN services on an actual potato. I am not digging a potato out of the ground and running FTP on it. There is a server there somewhere. That's not what we're saying. Basically, the thing is, when we look at architecture, again, you look at infrastructure as a service as we knew it up until a few years ago. Much of the resources that we were getting weren't very dynamic. You had storage, right? Dump file in, get file out. You had databases, put crap in, get crap out. You had computer, whatever else. But I mean, I don't want to say it was dumb. It just didn't do a lot of stuff, right? So if you wanted to encode video files, right, you would create an instance on AWS or Azure. You would install FFmpeg or whatever the product was in order to encode video files. And so you could create an encoding server, but you created an instance, you created a storage bucket, you did all the configurations, and so then your encoding server was up on the cloud, but you owned all of this, right? If you wanted to do AI functionality, you would literally build a damn AI server on the cloud and you owned all of that. If you screwed up one of the security configurations, everything could kind of go to hell. So why serverless architecture is so cool and why this is so revolutionary is now you can call processing as easily as you could call storage or database services before. So with serverless architecture, when I started playing with it, is Azure's, it's called AI Cognitive Services. It is AI-like services that basically you could simply access, right? So if you wanted vision functionality, instead of creating a Linux box, installing OpenCV on the Linux box and doing all the configurations, with your Python code, you can just connect to their server. You can send it, basically what happens is you just send the file or the video stream and it just sends you back a JSON. Now I know it's 2024 and you're like, yeah, why is this cool? I'm telling you, it's cool. It's not how it used to be, right? So again, like I said, if you're using AI services now, use something like Whisper. The fact that you can simply send up an audio file and it simply responds with all the text in the audio file, that was something that didn't exist that long ago. And that's why serverless architecture is so cool. And again, with this kind of thing, you're no longer worrying about operating systems and all that kind of thing. You're just paying for the resource. Oh, again, I want with LLMs or with image generation, I want an image created. I don't care if it's created on a Windows machine or a Linux machine or whatever else. I just want an image created based off of what I need. You send it up to OpenAI, you pay your 4 cents, they give you an image back. That's basically what we're talking about with serverless architecture, and it is absolutely awesome. And it still does use servers. Let's see here. You get reverse proxy servers. So again, talking a little bit more about architecture and all this. Basically what reverse proxy servers allow you to do is, again, load balancing. So one of the things you'll notice I talk a lot about is load balancing and failover. And so imagine you're dealing with a lot of traffic coming into your site or coming into your application, right? And so one of the concerns is basically bottlenecks. And like, what if one of your servers just kind of freezes? It doesn't crash. Again, it doesn't hard fail. Hard fail's easy to deal with. Just, I don't know, it's janky, it's quirky. Right, you got all kinds of users coming in. If all users are going to this one server, that one server starts acting quirky, things can be bad. So one of the things you can do is you can use something called a reverse proxy server. So again, we create the bottle web applications, and we did the class on deploying bottle web applications. We used Nginx. Nginx can be used as a reverse proxy server. And essentially what happens is you put the reverse proxy server here. As a user comes in from the outside world, basically they hit that reverse proxy server. Behind this reverse proxy server is essentially any number of more or less identical servers. Right? So let's say you have a WordPress site or you have your site. So imagine this is where the front end is. The front end is here, and then they all connect back to some kind of database system down there. And so basically what happens is somebody comes in, the reverse proxy server looks at the load on the different servers and then routes to whatever server has the least load. And when the next person comes in, it routes to the next and the next and next. And then it looks and says, okay, we'll route back to this one. And then this crashes, it has a hard fail, so it says, okay, we're not going to route to them anymore, we're going to route to these other ones. And so basically all a reverse proxy server does is it manages traffic to, again, more or less identical systems that are sitting behind it, again, for failover, load balancing, and that type of deal. Let's see here. Beyond reverse proxy servers, we also have a GeoDNS. So this is a cool one in the modern world. So everybody's worried about latency. And again, I will warn you, I do think people have a latency fetish. It's 2024. Does latency really matter that much, right? So again, you go back 15 years, latency was a big deal, right? So we're talking about latency. Latency is how long it takes the packets, the data, to get from the server back to the user. All right, so again, you go back 15 years ago, so if you had a user in the United States, anyways, and you had a server in Africa. So the user is here, the server is in Africa. And so your request has to go all the way to Africa and then has to come all the way back from Africa, right? So the latency is going to be the time, how long it takes for that to occur. So now again, you go back 15 years ago and latency was a big deal. In the modern world, is it? It's a question, right? So most of the stuff, I would argue, things like FTP services, a lot of other services, latency probably isn't that big a deal. On the other hand, if you're doing real-time communication, RTC, you may see WebRTC. Basically, this is voice and video communication. Latency matters, right? If there's a second delay. So if I'm downloading a Netflix video and there's a second delay between when I click and when it plays, does it really matter? Right? If there's some quirkiness in the buffer while it's downloading the video, doesn't matter. Again, probably not. That's why I say latency is a bit of a question mark to me. But if I'm actually doing a video call, or I'm doing an audio call, or I'm playing a video game, you put 1 second of latency in a Call of Duty streamer's game and all hell's gonna break loose, right? So that's where you want the user and the server that they connect to be as close as possible. The issue that you get into, though, is with normal DNS services, right? What does DNS do? DNS, domain name service, basically resolves domain names to IP addresses, CNN.com to 54.66.24.5. But that's how it was in the old days, right? So basically you had, domain name to IP address. But the problem is, right? Again, what about this latency? What if this IP address, resolves to a server in Africa, and again, you're dealing with real-time communication. That kind of sucks. And so that's why you got GeoDNS. And so what GeoDNS allows you to do is basically allows you to put your servers, so he's there, or they're there, and then it allows you to put your servers all over the world. So you create your little data centers all over the world because you care about latency. You're not like Eli, the computer guy. Latency matters to you. Now here's the thing, right? So now you have this streamer here. And so this streamer, goes out to DNS and is going to resolve your domain name. So Crappy App, I actually own Crappy App. So they're going to resolve crappy-app.com. What GeoDNS can do, is it can see where you're at. And based on where you're at, it can give you the IP address for the closest server. So instead of, getting routed all the way to Africa or whatever else, coming up with some kind of wacky ass system, you can put the configurations in to say, okay, anybody from this area is going to resolve to this server. Anybody in this area is going to resolve to this IP address. Anybody down here is going to resolve to this IP address. They're all using crappyapp.com as the domain name, but the IP address that resolves to changes based off of where they're physically located. And so that's basically what GeoDNS does for you. And again, it can be something very powerful. Though I'll tell you, I'll just put it out there, does latency actually matter? Again, especially if you're going to put stuff up in the cloud, one of my arguments is St. Louis, I don't know why, St. Louis has a lot of data centers. Before you go to all this mess, I'm just saying spin up your instances in St. Louis and see how you do. That might be fun. Might be fun. I'd almost put $5 that it will be fun. Oh, Jock. Oops, no, ask to what the fuck? Yeah. Jock, what's up?
Is that how TunnelBear works? In one of our examples we did in class, you use TunnelBear to access a server over in Europe. So does that kind of work the same way?
No, TunnelBear is its own thing. TunnelBear is its own after class, if I remember.
Okay,
Yep.
that works.
Yep.
But so for instance, geoDNSing, if we can set that up to, we gotta use that to kind of like again, latency, but also it depends on what we're trying to do exactly. Like if we're trying to access, say for instance, we want to put together a website where we're checking, food prices over the East Coast, and we want to access a lot of those servers over there, to get information. Would something like this work in that sense?
No, that would be a VPN. So this is where your users get routed. So this is like we'll talk about it in a minute. It's more like for an actual legalistic standpoint. What is it called? Regulations, data sovereignty. Right, so there's something called data sovereignty. Many countries now require that users' data be stored in their country. So if you're dealing with Facebook or whatever else. So like with GeoDNS, if you're dealing with this, basically, right, you have, crappyapp.com. You're collecting information about your users. And so again, so if your user is in Europe, you use GeoDNS to direct them to the server in Europe, so that all that data then resides in Europe. If your user is in the USA, you then send them to the server farm in the USA, so all of their data is stored there. So when we're talking about GeoDNS, this is basically where users get redirected to, and it's getting redirected to your infrastructure. There we go. Yeah, lots of products, lots of things. It's technology. Again, as I say with technology, just so everybody understands, technology's easy. All this shit, it's easy. It's easy. It's tying the 200 products together into something that an end user can actually use. That's what gets complicated. And again, it's a lot of words. Again, like I say, with like the difference between GeoDNS and VPN. So with VPN services, you as the user are deciding essentially where in the world websites think you're coming from. With GeoDNS, you're determining for the user where they're going to be redirected for your infrastructure. Let's see here. Let's scroll up. Oh, we still got so much. God damn. Caching and CDNs. So this is going to be a big thing with cloud computing, especially if you're going to be dealing with content. Again, things like video content, images, that type of thing. Again, we start talking about latency, that type of deal. So basically with CDNs, it's kind of like GeoDNS, sort of, almost in an automatic fashion. So what caching is, all caching is when your requests, or the response for your request, go through different systems, that they literally just save the information that goes through, so that instead of you having to go all the way out to the main system again, you can just get that local response. Caching is absolutely awesome. If you are not playing with caching, you got to start playing with caching. Basically what CDNs are, is an infrastructure level system for caching. Right, so again, we have the world, we have the USA here. We just have a blob for the USA. Okay, so let's say you have your main server farm is in the middle of the United States, but again, you're worried about latency. But you don't want to build all these data centers and all that kind of stuff. So what you can do is you can buy services from a CDN, a content delivery network. Basically, Amazon has their version of CDNs. Lots of these companies have CDNs. So they have their data centers all around the country. What happens, right? What happens is if a user here wants a piece of content, wants an update for your software, wants a video file, whatever else, what's going to happen is when they make a request, they're going to get auto-routed to the local CDN, whatever server is closest to them. It's going to make a request and see if there's anything in the cache. If there's nothing in the cache, it is then going to pull from your main repository to this system, and what's going to happen is it's going to cache it in the system, and then it's going to send on the file to that user. Then, what's going to happen in the future is if you have another user and another user and another user in the area, instead of them pulling all the way from the repository, they're going to go to the local CDN, they're going to find a copy there, and they're going to get the request back. So basically, they are just going to go to that CDN server instead of going all the way back to your main server. And so basically, that's the idea with the content delivery network. And so this can be very useful. Again, if you're spending money on like storage, so how much money you spend on storage, you don't want to store a lot of data or you don't want to pay for a lot of data to be stored that's not getting used. So basically, the storage here is only what actually is requested. So if you have 1,000 video files, but currently only 5 of them are what anybody wants to see. Those 5 will get moved around in the CDN, and the other 1,000 will sit in the repository. If somebody actually wants one of these in the 1,000, that will then go out, that'll get stored in that local CDN, and people will be able to access it from there. And so when you talk about a CDN, a content delivery network, essentially all you're talking about is an automatic kind of caching system for these types of files and things. Can be useful. Do be careful about prices. So like Amazon, I used Amazon CDN back in the day. And one of the interesting things is you got charged. So you got charged when your file went from the repository to the CDN server. You did not get charged when it went from the CDN server to the users. Here's a problem. I have a very international audience. I have a not particularly big, very international audience. So basically, every time a file was requested, it went to the CDN, and the only person that ever saw it was the one person that was requesting it. And so I got charged a crap ton of money for that CDN. And it ended in a bit of an argument. So be careful with CDNs. That's what CDN is. When we start talking about clouds, so again, the cloud, the whole idea of the cloud. So we talked about a lot of stuff here, virtualization, containers, all kinds of different stuff. And then we start getting into the idea of public, private, and hybrid clouds. So basically what a public cloud is a public cloud is what we've been talking about, right? AWS, Azure, DigitalOcean, Linode, those are public clouds. Those are vendors of cloud services. You swipe a credit card and you get access to them. Then you have private clouds. So again, private clouds are where you own the hardware, right? You have a cluster, a cluster of physical MySQL servers or database servers that are doing their little replications. You have a whole, type 1 hypervisor setup, and it's doing its thing. Again, when we talk about the cloud, the idea of the cloud is just logically, something's going on over there, right? And so public is DigitalOcean, private, you own it. Then you get to the idea of hybrid clouds. And this is basically what you should be building in the modern world. And the idea with a hybrid cloud is that your infrastructure spans not just your local cloud, but also, again, somebody's cloud online. So again, AWS, Azure, that type of thing. I will say Azure is very good for this if you are tied, if you're married to the Microsoft stack, because basically you can connect your Active Directory infrastructure into services up on Azure, and then basically your cloud can talk to Azure's cloud, and it's all, as seamless as Microsoft ever makes it. The nice part about this is, let's say you have a replication strategy. So let's say you have a database. So you're using MS SQL. So MS SQL is, Microsoft SQL Server. So you're using MS SQL, locally, and you have that kind of thing going on. You replicate that up to an MS SQL, resource up on Azure. The nice part there is if your building burns down, if you replicated everything properly, all of your data is up on the Azure cloud, just as good as you want it. Again, it's interesting to actually have Active Directory up in the cloud, a whole bunch of other things. And one of the ideas is you can actually use this as a site. So once you start building out architecture, there's something called sites. Basically what a site is basically any location, essentially, where you have your data centers. And so from a failover standpoint, the idea is that if one site fails, if you've replicated everything over to a different site, theoretically that can be used to provide resources to your users, especially in an internal infrastructure. So one of the cool things was with Azure, you can essentially make it its own site. So if a biblical flood destroys your home office, with a little bit of configuration, you can now point all of your users up to the Azure cloud, and they will get most of the functionality that they need. That's the kind of thing to be thinking about with like hybrid architectures. Also, a disaster recovery as a service. So there's a company called Veeam. If you don't know Veeam, learn about Veeam. They used to be one of my sponsors. Until I talked about Trump, and they dropped me like a hot potato. They were one of my best sponsors. And then I talked about Trump, and it all went to hell. Anyways, they're good. They're a good company, though. So basically what Veeam does is they are backup and really disaster recovery software for virtualization. They're really good with something called Hyper-V. So Hyper-V is Microsoft's virtualization product for local. The interesting thing, right? So basically, you have a Hyper-V, server or cluster in your local premises. The cool thing with Veeam is you can actually back up the entire instance onto a third-party cloud provider. Right? So essentially, think about it as an offline backup, but it's actually a usable instance. And the cool part is, with that particular third party, I forget the name of it, is again, if a biblical flood destroys your premises, you can actually spin up all of your instances within their infrastructure so that your users, especially if you have a remote worker, workforce, they are able to access everything that you had backed up there, basically just as normal as ever. Again, you change a couple of IP address settings, you do a couple of things, but basically, like literally, a biblical flood takes out your headquarters, and if you're using this particular solution in like an hour, you can have all of the services back up and running for your users, and frankly, you're paying for it through the damn nose, but it is functional. So that's one of the things to be thinking about, again, like with that hybrid cloud environment. The other thing, too, to be thinking about with the hybrid cloud environment, we'll talk about cost in a little bit, is things cost different. Like, what is cheap? What is cheap or expensive really depends on your utilization and what you need. And so one of the things to think about is compute and databases are dirt cheap on the cloud. Azure, AWS, who the hell cares? Dirt frickin' cheap. Again, you can go to DigitalOcean, you spend $15 a month, and you just get database. It's awesome. Spend another $5 a month and you get, wet server. The thing is, storage gets expensive, right? So if you go with Amazon, AWS, it is 9 cents per gig outbound in cost. So one of the things to think about, let's say you want to create a YouTube alternative. Right? You're going to create a YouTube alternative, and you wanted to build it in the modern architectural style. Well, if you wanted to build the front end and the user system and all of that kind of stuff, that makes sense up on AWS or whatever else. But if you're going to be doing YouTube, right, you're going to be ingesting a lot of video files. You're going to be sending out a lot of video files. And if Amazon is going to charge you 9 cents per gig, that's going to get expensive stupidly quick, right? So when I upload one of my files to YouTube, it's about 30 gigs. I just gotta admit, my 4K version here literally is about a 30 gig file. So if you watch me and, my 4K wonderfulness, let's say that's 10 gigs of download from a server, that means you get charged 90 cents for every time somebody watches one of my 4K videos. It doesn't scale, it doesn't take too long before that will bankrupt you, right? So one of the things you can do, again, with kind of hybrid infrastructure, and really thinking about this, thinking about what you're building, is you put your compute on the cloud. You put your database on the cloud, because that's dirt cheap. You then connect to a facility, a co-location facility, for $1,000 a month. You buy a rack, you rent a rack, and then in that rack, you spend, let's say, $30,000, in order to build a little storage array. So you build storage array, with replication, so if something fails, you're okay. And so for $30,000 plus $1,000 a month, so the first year is going to cost about $42,000, you have this storage array. And here's the thing, if you get hammered, if you get hit, lots of people come in, right? The only restriction is going to be that pipe going out. So this is a 1 gigabit per second pipe. So if you look at a 1080p stream, that's about 3 megabits per second. So 10, 100. So you can basically have 300. You can have 300 concurrent streams going out of a 1 gig pipe. Again, if you want 600, then you have to spend some more money. But you know, for $42,000 for the first year, you can have 300 concurrent, continuous streams going out of this, and this is what your final cost is. If you're creating a alternative to YouTube and it becomes successful, and you're running your storage off of Amazon, and you have 300 concurrent streams, how much money you got? And so that's the kind of thing to be thinking about too, again, with this hybrid cloud infrastructure, is again, again, what problems are you trying to solve? What resources do you have? That type of deal. Orchestration software. So this is down here. Orchestration software is, so in this modern world, again, we start talking about public clouds and private clouds. We got instances, we got containers. Again, we got services, we got microservices. How the hell does anybody manage all this crap? That's where you have what's called orchestration software. So what orchestration software allows you to do is it allows you to connect to all of your disparate systems, and hopefully allows you to manage and maintain them. So if you go back 10 years ago, Puppet and Chef were the big ones. Ansible, I think Ansible is the current cool one. We'll have a class on Ansible at some point. OpenTofu, I just went through a session on OpenTofu. That looks pretty cool. But basically what this software is this is essentially the orchestration software is software that is supposed to allow you to be able to manage all of your systems in a reasonable fashion. Because again, like the issue that you run into, this is a real issue, right? So you spin up instances, right? So you got your web server, right? You're like, ooh, I like this whole reverse proxy idea. So, you create your Nginx reverse proxy here, and then you spin up, God knows how many web servers. So you got some good load balancing going on, right? You got all the load balancing. Here's my question. So what patches have been applied to this one? Are the patches that have been applied to this one the same as the patches that have been applied to that one? Is this server running the same version of Ubuntu as this server is? Yeah, you don't want to manually try to figure that horse crap out. And that's what orchestration software tries to help you out with, is basically gives you, again, that kind of single pane of glass idea. Okay, here are your 20 web servers. These servers are at this version, and these servers are at this patch level. Again, you start talking about things like configurations and firewalls and that type of thing. Basically, the orchestration software allows you to change all those configurations, hopefully in a reasonable fashion. And it also allows you to do things like fallback. So if you run an update on one of your servers, and it fails for some reason, because we are in the tech world and crap fails, basically with orchestration software, if it's good, it should allow you to fall back to the previous, what's called the previous state, so at least you keep everything up and running. Let's see here, vendor stacks and lock-in. Again, what I was kind of talking about before with AWS or Azure, one of the things you need to really be thinking about is the vendor stack. So all the technology that's required in order to make your product or your platform work. Again, if you are already married to Microsoft, you're married to Microsoft, suck it up, drive on. Right? Use Azure. That's how it is. But that's one of the things you need to be thinking about. Again, with all of these different cloud vendors out there, again, for your specific thing that you're doing, like you may be doing an IoT project, and in the IoT world, there might be a cloud vendor that is more focused on whatever it is that you're trying to accomplish. So that's one of the things that you need to look at. The other issue that you're going to have to be careful about, though, again, with those vendor stacks, is lock-in. Like what happens when you get locked into a particular vendor stack and things start going sideways, right? Again, the whole idea of enshittification. You started using them, 5 years ago, and 5 years ago, they were amazing. And then they got purchased by a private equity firm, and now they're crap. One of the things you're going to have to think about is how locked into the platform are you, and is there a way to get out? One of the big things they talk about is things like data portability. So the idea with data portability is literally, can you get your data out of the platform, right? Again, especially with software as a service, right? Salesforce. If you've put 5 years of data into Salesforce, are you able to get 5 years of data out of Salesforce? But one of the bigger things that you need to be thinking about, again, as a technology professional, not is it simply can you get the data out, but can you get it out in a format that you can do something with? So again, I remember about 12 years ago when the whole data portability started becoming a question, I used a particular service that said they had data portability. You want your data, you got your data. And yeah, so I was like, cool, I want my data. I don't know what I got. I got data. Pretty sure it was mine. It was just this garbage format. It was just like, you're like literally looking at this thing, and it was like 20 tables, and you didn't really understand how anything connected to each other. And you're like, yay, I got my data. It's not actually usable though. Something to think about, again, from the decision maker standpoint. The other thing to be thinking about, again, with lock-in, is if you do want to get your data out, how expensive is it going to be to get your data out? If you basically have a basic database system going on, a CRM solution, something like that, you want to pull your data out, you got a few gigs of data, fine, you pay 27 cents or whatever to Amazon, it's no big deal. Again, if you were creating an online backup solution, again, if you're creating an alternative to YouTube or whatever, you uploaded all of these files onto their platform, generally ingestion is free. So when it goes in, it's normally free. It comes out, that's when they charge you through the nose. You put up, 200 terabytes of data into Amazon, you decide to pull 200 terabytes of data out of Amazon, you may not have the budget to be able to leave Amazon. So that's one of the things to be considering. Again, is the cloud secure? Again, this comes up, talked about it before. One of the things you have to be thinking about, again, with the cloud. Again, the cloud is just an architectural style. That's all it is. Nothing to get that excited about. Is it secure? Secure as anything else. Again, if you've had employees, all I want you to do, when you think about is the cloud secure, I just want you to walk out with a cup of coffee and I want you to look at your employees. Then all I want you to ask yourself is, how much do you trust your employees? Do you trust Microsoft more than you trust your employees? It's a question. Disaster recovery in the cloud. Again, one of the things you need to be thinking about, I've talked about like failover and that kind of stuff. That's great. But one of the things you do have to be thinking about is what happens if your as a service vendor dies or literally goes up in flames. What happens if your as a service provider goes bankrupt? This kind of thing happens. Again, let's say you're doing an IoT platform. And so you find a cloud provider that gives you all the crap you need to build your IoT business. What happens if they go bankrupt? Like seriously, have you thought about that? That's one of the things you need to be thinking about with your risk management plan. Is your backup provider simply using the other vendor on the back end? I've actually seen this. This has been well documented. Where so some cloud vendor goes poof, right? So something happens, right? Everything goes down. But you're like, no big deal. We have failover. I listened to Eli. We have failover. But what happens if your systems fail over to a vendor who uses the original vendor for their back end? Right? This is a real big issue, especially with AWS, right? AWS is used by everybody. So you may be sitting there and like, okay, well, we know AWS is used by everybody. So we've got a budget. I can spend that $10,000 a month. So we're going to have our AWS, we're going to set that thing up, and then we're going to go over to this entirely different vendor, and we're going to set up, a redundant, cloud infrastructure over there, do the replication strategies. So if AWS goes down, because a region might go down, then we know they're up. And you don't realize their backend is AWS. This is real. Be careful about it. It happens. So again, these are some of the things that you've just got to be thinking about. And again, get really creative. When you think about disasters, go out. Get some of the best alcohol you can find and just sit there and spitball about stupid crap that might happen to your infrastructure. And the funny part is, then have somebody Google what you say, and you'll probably find out it's already happened. So again, that's the kind of thing you need to think about. We're talking about disaster recovery as a service, multi-cloud architecture. So this is a concept, again, that's been talked about more and more. People worry about vendor lock-in. So they're like, we're going to use Azure and we're going to use AWS. We're going to use a multi-cloud environment. Yeah, my question here is, really? Do you really want to do that? When you start doing things like multi-cloud environments, it gets incredibly complicated. It gets incredibly expensive, and there really does have to be a real question about, are you actually getting a hell of a lot more value out of it? Again, do be careful with that kind of thing. Regulations, again, your job goes beyond configuration files. PCI, HIPAA, GDPR. Basically, vendors will tell you if they comply with these laws. So one of the things, again, as a technology professional, your responsibility is to find out what the regulations are around your particular environment. If none of this crap matters, don't worry about it. But if you're dealing with personally identifiable information, if you're dealing with medical records, if you go within like 5,000 miles of Europe, make sure you understand what regulations you're under. And one of the things that you'll find with a lot of these cloud services is they literally just tell you, we are PCI compliant, we are HIPAA compliant, we are X, Y, or Z compliant. And again, with a lot of this kind of stuff, when you talk about personal identifiable information, it'll be things like are physical servers secured behind some kind of door security system, that type of thing. Is there encryption at rest? Is there encryption at transit? Is it to a particular level? And the thing is, these kind of services will cost you a little bit more money, but again, if you need to use it, better go with them than somebody else. Again, data sovereignty is going to be a bigger and bigger issue. Again, NSA, our government, the American government really likes to shoot the American economy in the foot. Miserable ways. Again, whoever is in the administration. And so one of the problems, like with the NSA doing what the NSA does, is basically they make it so that the rest of the world loses trust in the United States. And as an American, I get it. I understand. I want to trust us either. Right? So when you have the NSA literally spying on American data centers, right? Literally putting man-in-the-middle attacks between Yahoo's two data centers, right? Other countries get a little bit nervous about this. And so that's where you get to data sovereignty. So again, if you're dealing with French users, if you're dealing with Spanish users, especially when you're dealing with Europe, again, if you actually have a real financial presence in those areas, you need to be thinking about where does that data and everything get stored. And one of the things you might find out is, again, by law, it has to be stored in a particular geographic area. Again, even though it's in the cloud, right? The internet is globally accessible, but it's still physical in a way. So anyways, things to think about. And then finally, oh, thank golly, finally we get the total cost of ownership for your architecture. One of the things you need to be thinking about, again, as you build out all of this kind of stuff, is what is this architecture going to cost at the end of the day? And do you have the institutional ability to continue to maintain it, right? That's going to be a big, big, big issue, right? You get some 19-year-old intern in there that's a master of the Linux world, builds out all these amazing clusters, gets hired by Microsoft for $500,000 a year, and now you're stuck trying to maintain the crap. Seen it happen. That's the kind of thing that you need to think about. Again, you start talking about MySQL. Again, what is your institutional knowledge when you start thinking about cloud? All right, so you can go to DigitalOcean or whoever else, and you can connect to a database service. You literally go, you swipe your credit card, $50 a month, whatever else. You just get a database service. You use the credentials, you're able to go in, you're able to do everything you do in a normal MySQL database. You get the cloud, you get the reliability, you get the safety, you get all that kind of stuff. And, it's so easy, you can do it. Or again, you sit there and you're like, well, but I want to own everything, so I want to create my own cluster. Well, again, if you create your own cluster, you need the knowledge and the ability to actually be able to build and maintain that cluster. Not only that, you need to buy all the machines in the cluster, right? So $15 a month. $15 a month gives you a DigitalOcean database service. Each one of these servers is going to cost you $1,000, right? You spend $5,000 on a MySQL cluster, plus all the time and energy it took to build it. And again, the CFO is going to be like, we could have gotten the same service out of $15 a month. Right? These are kinds of things you need to be thinking about. Again, whether you go with AWS or whether you go with Azure, what is the institutional knowledge? If your company has 20 technology employees and they're used to a particular environment, go with that environment, right? If you have 19 employees that understand AWS and one that understands Azure, or vice versa, you really have to think, why would you use the other service? Again, everything from management consoles. Again, it's amazing. You go into Azure anymore, like Azure wasn't that bad. 5 years ago, Azure wasn't that bad. You go into Azure anymore, it's hell. It's just, the management consoles just make you lose your mind. And again, that's the thing. Like, so if you have people that are not used to the Microsoft environment, they're now trying to maintain your cloud infrastructure within a management environment that they do not naturally understand. That's not going to be good for the maintenance and the upkeep of your systems, that type of deal. And yeah, there we go. And that, my students, is Introduction to Cloud Computing. Lots of stuff, and there is so much more I did not get to. So yeah, there's no labs today because just a seminar class. Does anybody have any questions? Out of everybody that's left, anybody have any questions to ask about cloud computing? Dun, dun, dun. Is anybody awake? I know Wayne's awake. Wayne's driving. I don't know how I feel about Wayne driving, but Wayne's driving. Don't worry, I won't kill myself. Oh, let's see here. Wayne, are you talking to me? I can't hear you. You're muted. I don't know what Wayne's doing. I don't know what anybody's doing. Okay, so questions. Got some people left. Any questions? There's no questions. I'm on a roll. Got some good beer to drink tonight. For my marathon. Okay, so yeah, that's about it then. Oops, we got a question from Nazir. What's up?
Yes, can you hear me?
Yep.
Okay, I had a question. When it comes to security, like the IP, all that kind of stuff.
Yep.
Why do you think companies care so much when, like for instance, if I'm working remote, I could work from remote anywhere in the U.S. But what is it about out the country that matters so much, especially considering the fact that some of these companies that have remote workers, they hire people from other parts of the world, and they don't seem to care about security then. All of a sudden, if I come from the U.S. and then I want to go somewhere else, all of a sudden it's a security vulnerability. Like, why all of a sudden it's a vulnerability when I go, but they'll hire someone in India and no one cares?
Well, one of the questions might be like what your position is. Like, you know, I may hire HTML developers in India and not give a damn, and whatever your position is, like they're paying you an American or whatever salary for hopefully for a reason. So it might be what your job position is. It might be whatever their contract is. Again, I don't know what company you're working for, but like if you're working for a company that does things like government contracts, that type of thing, they may stipulate for specific projects where people might be located. And you might also just kind of have crappy management. Like some manager, like we're getting into a weird thing with managers nowadays where, again, don't get me wrong, I complain a lot about employees, but managers are employees too. Like, you get this weird stuff, like they want to have like some control, like why should I pay you this amount of money when you're working from Portugal? Which, what does that have to do with anything? But they do get into that weird ass mindset. So what I would say is probably like if this is actually with your company, at some point grab a cup of coffee with somebody in your company and just like literally just ask them why they do what they do. It might be enlightening for you one way or the other. So I mean, it really does depend on, you know, who you're working for and that type of deal.
Okay,
Yeah.
makes sense.
Cool.
That was all I had.
That's all you had? Okay, that works. Yeah, managers. You know, sometimes they're playing 4D chess. Sometimes they're idiots. You know.
Also, I do work with Salesforce. So if you ever want to get deeper into that more, I'm all for the Salesforce talk. That's my main specialty that I do every day for the past 8 years.
Yeah, that's cool. I appreciate that, but no, I do not want to get anywhere near Salesforce.
Thank you.
Cool. Yep, no problem. Okay, so let's see here. And we got Wayne. What's up, Wayne?
Now I'm unmuted. I guess I had to raise my hand first.
Yep.
And get you to unmute me. I was doing it the other way around. It wasn't very effective. You're a fantastic teacher. I feel honored just to be live with you. I've watched a million of your, as I'm driving around at 2, 3 in the morning, doing service calls. And listening to you. You cracked me up, man. Your sense of humor is awesome. I'm so sorry what happened to you, recently with the biblical flood. That's incredible. I mean, you're obviously a very strong person that you're still able to get back on track, sort of, and ride the horse again, and do your job. Yeah. So I'm just trying to, to say how admiring I am of you, and I'm sure many others are saying the same thing. So, and I look, where's this class going to take us? This is cloud computing intro. Yep. Is there going to be like a phase 2 of it, or?
So this is a seminar. So all this stuff is, I don't know, it's leading us somewhere, I guess. So I'm trying to figure out with these classes, because I am trying to standardize this a little bit, but I'm doing it as I go. So I'm trying to do one seminar, because this is relatively easy for me to create. So one seminar and then one practical class per week. And yeah, I'm not quite sure. So we're gonna do a class in Introduction to Architecture. So we're gonna talk more about mainframe and application servers and client servers. And so I don't know, we're going that way.
Will that be part 2 of today? Is there does this continue next week, some TV episode where every week it's a new chapter of the same topic, or no?
So yeah, so no. So what I would like to see with these classes, my overall goal is, again, with Silicon Dojo, again, this is based around the whole martial arts system. And so with that, it's we're kind of going in a path, but if you miss a couple or come into them you should be fine enough. It's kind of like the old Matlock, right? If you watch the old hour-long shows back in the 90s, you could come into the middle of a show and still be able to keep up with things. And so that's what I would kind of like with this program, is that everything is rather compartmentalized, so that you can come into almost any class and understand what's going on in that class. And then as you go to more classes, all the parts start fitting in. So 5 weeks from now, you're oh, that's what a cluster really means, that kind of thing. That's my thought. Yeah.
And would that lead to a job role, a position in the industry? I don't mean you recommending this. I don't mean that. What I mean is, where will all this education take us? Or is it just a la carte? People can pick and choose from YouTube and say, I want to learn that, I want to learn this.
Yeah, so a lot of it's going to be a la carte. Here's the problem. So again, I've been doing tech education now for 15 years, 2009. And the issue that you run into when you start talking about jobs is people just get dumb. And because you're doing technical work. The thing is with our field, again, it's like with coding, right? If you fuck up, if you don't put a comma in the right place, 100 lines of code literally doesn't work. And VS Code doesn't catch it. There's so many times VS Code doesn't catch stupid little errors. And so you have to have the drive, not the passion, the drive, for if this code isn't working, and you're pretty sure it should, that you're going to sit there for 8 goddamn hours and figure out what the fuck's going on until you find that one little comma. And so the problem is when I start talking about jobs, anytime you talk about jobs, right, people don't want this job. People want money. People want respect. People want all this horse crap they think being a technical professional is about. They don't want the job itself. And so, I don't really want to focus on jobs, because then that takes us down just a really bad path. Again, when I do the in-person classes, so again, in Nashville, probably about 2 weeks they'll start, and Raleigh, a couple months they're going to start. If I have people that are interested in technology, if I have 20 people in the class that are interested in technology, that is a wonderful class. If I have 2 people that are interested in technology and 18 people that want jobs, It sucks. It is miserable. And so basically, my thought with jobs and all that kind of stuff with this is I'm teaching you the real skills, right? This isn't some fake programming language to teach you logic or whatever. This is the real crap. And so basically, if you can take this to get yourself a job, yay! So like that's the whole thing. Like again, as a technology professional, we solve problems. So the more you know and the more drive you have in this field, the better you're going to do. But again, it's gonna be self-motivation, right? Are you gonna go to the meetups? Like that's the thing like I have like with mentorship and advisors. Like if I meet you for a mentorship meeting, like this isn't a once a week thing. This is I sit down and talk to you for an hour and then you spend a year implementing what I talk about in an hour. Too many people just want to talk. Like, hey, let's have a cup of coffee. What do you think about cloud? What do you think about Python? It's like, you want a job. Okay, these are the things that you need to do. Go out, talk to these people, schmooze, do X, Y, or Z. Come back to me after you've done these 20 things, and then we'll reassess. And so that's the thing. It's like, if you have drive, if you have motivation, if you're going to go out and you're going to kiss ass, if you're going to do all the things that I talk about, I have very little doubt you'll get ahead in your career. But I don't want that to be the focus of this. That makes sense?
Yeah. Where I was going with that is like, I was considering like a junior cloud engineer because I'm too old to ever become somebody really good at it. Yeah. And the reason I was doing it is because of my age. It's because right now I'm a field engineer. I do like EMC. Yeah. And there might come a day where I can't climb ladders or carry heavy equipment. So I was contemplating cloud engineer where I could ride a desk. It's like getting involved in IT studying. Yeah. It's like I can end up in the wrong direction, but that's okay. I'm kind of focusing on it. I don't expect you to answer it. Yeah. But I'm kind of sorting out what I need to learn and what I don't need to learn because as we all have learned over the years. You got to really just do what you need to do and nothing else, because otherwise it'll take a lifetime just to learn one topic. Yeah. So, but thank you for everything, man. Your class is great. Yeah. Go enjoy it.
Cool. Yeah, and that'll be the thing too. Is like, for your area, that's I don't know where you're at, but again, like I say, like the meetups and the tech events is again it's like so much of tech skills. It's geographic. I talk about that when I got my MCSE. So go back to 2000. So you get your Novell network engineer or MCSE. And the weird part was West Coast was Novell, East Coast was Microsoft. That's just how it was, right? Again, if you go back a number of years ago, Ruby and Python, or Ruby and PHP. West Coast was Ruby, East Coast is PHP. It's just kind of like where you're located. And so that's the thing, is also like wherever you are, that's why I say the meetups and the tech events, and you go talk with people and you find out what they're actually interested in. And the other thing too is I'd be careful. I mean, I don't know how old you look. I'm getting older, so everybody else looks younger. Not quite sure how old you are. But don't, and I'm not buttering your ass when I say this. This is true. Don't undercut yourself. Because again, just because you're older, like there's this whole thing with ageism in our field. It exists. It's real. It's true. But you also have to think about a 20-year-old is much more likely to be poached than an older person. Like if you actually get a good skill level and people trust you, like are you going to work for Facebook? Fuck no, you're not going to work for Facebook. But you probably weren't going to work for Facebook when you're 20 either. But you might be able to get a good job somewhere that wants somebody to just come in and plug along and do the work. So again, with the ageism and all that is real, but also be cautious with it. It's like, it is, but it isn't. So, yeah, especially with wherever you're at. I don't know. Let's be careful with that one. Oops. Hold on, Wayne. Hold on. Where the fuck are you, Wayne? Wayne, I just unmute. What's up, Wayne?
Okay. Good, I'm unmuted.
Yeah.
I'm known as a big talker, so my boss mutes me in the Teams meetings. We have these big EMC thing. I'm outside of New York City.
Oh, okay.
Jersey. I'm in Jersey. Yeah. So anyway, I get muted a lot. And the rest of my coworkers crack up because they know I've said something wrong. Thank you for that info. I never really thought of it that way. I'm just trying to be realistic. So I need realistic paycheck.
Yeah.
Not like, I'm not trying to be a student, What I wanted to say to anybody listening to this is I work for a company that installs big, massive cloud systems for the banks. And when I said that, I'm talking JP Morgan, so on and so forth. And in New Jersey, most of your data centers for the stock market are right there because of latency.
Yeah,
I don't know why Bloomberg and everybody else, they had their core is right in New Jersey. It's crazy.
Yeah.
And it boggles my mind why your architecture, but those guys are really on top. Like I talk to a lot of the guys at the data center, they have their knocks right there, and I get to sit in a chair next to them as we figure out with Dell support what's wrong. You know what I mean?
Yeah.
And it's so cool. It's exciting. I get paid for it, but there's a lot of hours involved. I get paid. Overtime is where I make my money.
Yeah.
But it can be a 6-figure job if you're willing to work the overtime. And in today's world, that's good. So I just wanted to say that can easily be obtained if somebody is looking for it. But anyway, let me shut up. I'm done talking.
Okay, good call. Yeah. Yeah, if you're in New Jersey, you're in New Jersey. Yeah, go to meetups. Drink some free beer. Get some pizza. You might be surprised how far you can go. Okay, let's see here. Keith, and then I probably got to go drink my own beer. What's up, Keith?
Hello. Yeah, I was just really chipping in from what Wayne was just saying then, really. Just it's not really a question, I guess, but don't discount yourself. If you're willing to put the time in, if you're willing to put the study in, if you're passionate about it, it's not really even work either. Tech, it's a massive broad field, and I come from an IT background, and then over time I did a bit of business intelligence, data, and now I'm doing software development, .NET predominantly, but tech's massive. Don't discount yourself. If you're willing to put the time in, you're willing to put the effort in and learn about it, you'll get there. And there's no reason why you can't be as good as anybody else. I'm tutoring people at the moment where I work, new starts, and they're 20-year-olds, but they know a lot less than me. But you'll get there. They'll get there. They'll observe what I do and what I know and absorb that knowledge, and then they'll become experts in who knows. Maybe they'll move on to another field. Who knows? But don't discount yourself. That's basically all I'm saying.
Yeah. Good advice. Yeah, that's the thing. You just got to go out there and just got to keep. Because I think that's the thing. Like with my career, I mean, you got to look at it. It's like, I started off in the Army, electronics. Then I got medically discharged from the Army. Then I got in the .com boom, and then the .com boom went bust. And then I built a company with 9 employees, and then there was a Great Recession. And then I became a YouTube star. And then YouTube can't figure out what the hell they're trying to do. And so I think that's one of the things too, is like with so much of the technology is, again, I don't know if this is enjoyable. Like this is enjoyable. This is fun. I'm not sure how fun doing this was, writing this was. But it's more, again, like people talk about passion or whatever. Again, if you want to get ahead, it's like that, it's that drive. It's that, like, what the hell else are you going to do today? Again, you wake up in the morning, you're like, I hate technology. I'm going to do something else. And then you spend the day, going on a Monster or whatever, finding all these other jobs you could do. You're like, oh, they all suck. And then you go back to IP addresses. Yeah. So yeah, just keep trucking along, I'd say. So anyways, okay. And with that, it is almost 5 o'clock. So we're going to have a class on HTML5 APIs. That will be on Friday. So I get to write that class tomorrow. That's pretty cool. So basically, HTML5 APIs allow, in the web browser, you can actually do a lot of things that many people think you can only do with a native app. So a lot of people nowadays, like when they're going to create their startup company, like they spend a lot of money, like I have to create my iOS app, and my Android app, and my web app. And again, one of my arguments is just build the damn web app and then see if anybody cares about your products, and then worry about the iOS app. And so that's the thing, is like, I'll show you how to use HTML5 APIs with JavaScript. You can do a lot of cool functionality. And again, just with a web app, so you don't have to get Apple's permission, you don't have to get Google's permission or anything like that. So we're going to do that, and then we'll probably have an architecture class next week, then we'll have a different class. We just keep going. I don't know where we're going. We're going that way. going that way. We'll see what happens. So that is it. So I'll see y'all next time.